Hello, and welcome to the Sleepless Physicist. I'm really glad you found your way here, to this gentle pocket of the night where wonder and calm can sit side by side. There's something special about this moment, isn't there? You've chosen to be here, right now, in this exact configuration of time and space. And I want you to know that your presence matters. It matters to me, and it matters to the universe in ways we're about to explore together. Maybe you're lying down right now. Maybe you're propped up against pillows or curled on your side, finding that perfect position where your body finally agrees to let go of the day. I wonder if you can feel the weight of your blanket, how it drapes over you like a protective shield against the vastness of night. Is it soft? Heavy? Just the right amount of warmth? That blanket, that simple everyday object, is performing a kind of magic right now. It's creating a boundary between you and the rest of the universe, a cozy demarcation that says, here is where I am. This is my space, my moment of peace. Your room probably has its own quiet personality at this hour. The familiar shadows in their usual places, maybe the gentle hum of electronics, or the distant murmur of the world beyond your walls. The temperature of your room, is it cool enough that your blanket feels necessary? Or is it that perfect balance where you exist in thermal equilibrium, neither too warm nor too cold, suspended in comfort? These details matter because they anchor you. They tell you where you are, or at least, they tell you where you think you are. The screen you're watching right now, this window of soft light in the darkness, it's probably the brightest thing in your room. Its glow is painting your walls with shifting shadows as I speak, creating a private theater where you're both the audience and the stage. That light traveling from your screen to your eyes will come back to that journey because it's more extraordinary than you might imagine. But for now, just notice it. Notice how it creates a cone of gentle illumination in your dark room, how it makes your familiar space feel slightly different, slightly magical. I love imagining where you all are right now. Some of you are watching as the sun sets, using my voice as a bridge between day and night. Others are deep in the darkness. Perhaps it's 2 or 3 in the morning where you are, and the rest of your world is asleep. Some of you return here often. I recognize your usernames in the comments. See the timestamps from different corners of the earth. Tokyo at dawn, London at midnight, Los Angeles in that golden hour when the city pretends to slow down, Sao Paulo when the night sounds take over from the day sounds, Mumbai in those precious quiet moments, Cairo when the ancient and modern night merge into one. You're part of a scattered constellation of wakeful minds, all of us here together, yet magnificently alone in our individual spaces. There's something profound about that, isn't it? How we can be together in this shared experience while being physically scattered across thousands of miles. It's our first hint at tonight's deeper mystery, this question of what it really means to be somewhere. Because here's something beautiful and strange. As you lie there feeling perfectly still, you're actually hurtling through space at speeds that would take your breath away if you could feel them. Right now, the earth beneath you is spinning at about 1,000 miles per hour if you're near the equator, a bit slower if you're closer to the poles. But you don't feel it. Your cup of water on the nightstand isn't flying off. Your blanket isn't being ripped away by the cosmic winds. You feel still, perfectly, absolutely still, and yet that's just the beginning of your motion. While you're spinning with the Earth, you're also orbiting the Sun at roughly 67,000 miles per hour. Imagine that, 67,000 miles and every single hour, a cosmic racetrack that takes a full year to complete. But again, you feel nothing. No wind in your hair, no force pushing you back into your bed. Just this quiet moment, this illusion of stillness. But we're not done moving yet. Our entire solar system is spiraling around the center of the Milky Way galaxy at about 514,000 miles per hour. And our galaxy itself? It's rushing through space, pulled and pushed by the gravity of other galaxies, part of a cosmic dance that's been going on for billions of years. When we add it all up, you're moving through space at speeds that numbers can barely capture, and yet you feel still. This paradox, this impossible stillness in the midst of cosmic motion, is where our journey begins tonight. Because if you're moving at such incredible speeds, if your location is constantly changing relative to the universe, then where exactly are you? Can you really say you're in your bed when your bed is on a spinning planet orbiting a moving star in a rushing galaxy? And if where you are is always changing, always in motion, then what does it mean to be in one place at all? These aren't just abstract philosophical questions. They're about to become very personal, very real, because modern physics has discovered something extraordinary about the nature of location, presence, and what it means to exist somewhere. Tonight, we're going to explore one of the universe's most beautiful mysteries, the question of whether you can be in two places at the same time. Now, I know what you might be thinking. This sounds like science fiction, like something from a movie about parallel universes or time travel. But what I'm going to share with you tonight is science fact, discoveries that physicists have made about the fundamental nature of reality. And the beautiful thing is, these aren't cold, distant facts. They're truths about you, about the atoms that make up your body, about the light entering your eyes right now, about the very nature of existence itself. I want to be honest with you about something. The journey we're about to take wanders through some of the deepest territories of physics, quantum mechanics, relativity, the nature of consciousness itself. These are topics that have made the greatest minds in human history pause and wonder. Einstein himself struggled with some of what we'll explore tonight. But here's my promise to you. I've wrapped every concept in the softest metaphors I can find. I've taken the mathematics and transformed it into poetry. I've turned equations into lullabies. You don't need to understand everything. In fact, I've designed this journey specifically so you can drift in and out of attention. Let the ideas wash over you like waves on a beach. Some will sink in deeply, others will simply leave a pleasant sensation and fade. Your unconscious mind has a way of absorbing what it needs, especially in this drowsy, receptive state you're entering. So there's no pressure to stay alert, no test at the end. This is a bedtime story where the universe itself is the storyteller, and I'm simply translating its whispers into words you can dream to. If your mind starts to wander, that's perfectly fine. If you find yourself drifting into sleep and missing parts of what I'm saying, that's not just okay. It's intended. The concepts we'll explore exist in that liminal space between waking and sleeping anyway, in that realm where logic becomes fluid and impossible things feel naturally true. Some of the deepest insights about quantum mechanics have come to physicists in dreams, in those moments when the rational mind relaxes its grip and allows paradox to simply be. I should mention, too, that this video is designed to be experienced multiple times. Like a favorite bedtime story from childhood, it reveals different layers with each listening. The first time, you might simply enjoy the sound of my voice and the feeling of cosmic wonder. The second time, certain concepts might click into place. The third time, you might find yourself having profound realizations about your own nature, or you might simply use it as a reliable path to peaceful sleep. All approaches are perfect. If you're already finding yourself settling into this moment, already feeling that gentle pull toward rest, maybe this is a good time for a small gesture of connection. If you feel moved to, a gentle tap on the like button helps other restless minds find their way here. It's like leaving a light on for fellow travelers, a small beacon that says, Here's a place of peace, and if you're someone who's been here before, who's made this part of your nighttime ritual, I'm so grateful you've returned. Your presence creates the energy that makes this space what it is. I love seeing where you're all listening from in the comments. There's something magical about knowing that someone in New Zealand is starting their day with these thoughts, while someone in Iceland is ending theirs. We're scattered across every time zone, every continent, yet here we are, sharing this moment. Sometimes I read through your comments during my own sleepless nights, seeing your thoughtful reflections, your questions, your moments of recognition when something resonates deeply. It reminds me that we're all seeking the same things: understanding, connection, a sense of our place in this vast cosmos. Speaking of place, let's return to where you are right now. Look up at your ceiling if you can, or if your eyes are closed, just imagine it. That ceiling seems so solid, doesn't it? So still. It's been there all day, all night, unchanging. It's one of the constants in your life, a fixed point in your personal universe. But here's where our journey truly begins, where we cross the threshold from the ordinary into the extraordinary. That ceiling, that seemingly solid, motionless surface above you, is actually vibrating with billions upon billions of atoms in constant motion. Even in what seems like perfect stillness, those atoms are dancing, they can't help it, written into the fundamental laws of the universe, that nothing, absolutely nothing, can ever be truly still. What you perceive as solid matter is mostly empty space, with tiny particles zipping around at speeds that boggle the mind. The atoms in your ceiling are moving. The molecules of air between you and the ceiling are moving. The photons of light bouncing off the ceiling are moving at the speed of light itself. And this brings us to our threshold moment, the doorway between the classical world you think you know and the quantum world that actually exists. Because if nothing is ever truly still, if everything is always in motion, always vibrating, always dancing, then what does it mean to be anywhere at all? How can you be in one place when that place itself is a blur of motion? How can you be located when location itself might be an illusion? Take a breath with me now, a slow, deep breath. Feel the air entering your lungs, those molecules that were just outside you becoming part of you. And when you exhale, notice how part of you becomes part of the room. This simple act of breathing is already showing us how fluid the boundary is between you and not you, between here and there, between one place and another. So now, let's begin our journey in earnest. Let's discover together whether you really can be in two places at the same time. Let's explore what physics tells us about the nature of location, presence, and existence. Let's find out what you really are and where you really are. The answer, I promise you, is far more beautiful and strange than you might imagine. And it all starts with understanding motion, the memory that never ends, the truth that nothing in this universe has ever been still. Right now, as you lie there, perfectly motionless in your bed, you're hurtling through space at 67,000 miles per hour around the sun. But you don't feel it, do you? Your glass of water sits peacefully on your nightstand. Your curtains hang straight down. Nothing in your room gives even the slightest hint of this cosmic velocity. This is our first mystery, our first invitation to wonder. How can you be moving so fast, yet feel so perfectly still? The answer lies in something beautiful about motion itself. Motion has no meaning without comparison. You can only move relative to something else. And everything in your room, your blanket, your pillow, the air you're breathing, it's all moving with you at exactly the same speed. You're like a passenger on the smoothest train ever built, gliding so perfectly that without windows to see the landscape rushing by, you'd never know you were moving at all. But Earth's journey around the sun is just one layer of your motion. Our entire solar system is wheeling around the center of our galaxy, the Milky Way, at about 514,000 miles per hour. Try to imagine that speed. If you could travel that fast in a straight line, you'd reach the moon in less than half an hour. You'd pass Mars in a few hours. Yet here you are, feeling nothing but the gentle weight of your blanket. And even that's not the end of it. Our galaxy itself is moving, drawn by the gravity of other galaxies, part of a cosmic flow that astronomers call the Great Attractor. Everything in the universe is in motion relative to everything else. There is no fixed point, no universal reference frame that sits still while everything else moves. Motion is woven into the very fabric of existence. Do you remember being a child and spinning in circles, arms spread wide, head tilted back, turning and turning until the world became a beautiful blur? That moment when you stopped, but the world kept spinning. That's perhaps the closest your body has come to feeling the truth about motion. For those few dizzy seconds, your inner ear, confused by the sudden stop, kept sending signals of movement to your brain. You were experiencing what physicists call a change in reference frame. I remember doing this in my backyard as a child, falling onto the grass and watching the sky wheel overhead. The clouds seemed to race in circles even though I had stopped moving. Or had I? Was I still and the sky spinning, or was the sky still and I was somehow still turning? In that moment of childhood vertigo, I was touching something profound about the nature of reality. There is no absolute stillness, no cosmic stage that stays fixed while we perform our movements upon it. Think about this. When you spun as a child and then stopped, which version of the world was real? The spinning one you saw or the still one everyone else experienced? The answer is both. The answer is neither. The answer is that motion and stillness are not opposites, but different perspectives on the same thing. And this isn't just philosophical wordplay. It's the foundation of Einstein's relativity, one of the most tested and proven theories in all of physics. You're like a fish who has never known anything but water. Can a fish understand wetness when it has never experienced dryness? Can you understand motion when you've never experienced true stillness? We live our entire lives embedded in motion. The Earth's rotation, its orbit around the sun's journey through the galaxy. These motions are our water, invisible to us because they're all we've ever known. But let's go deeper, much deeper, into the heart of what you're made of. Let's shrink down beyond what eyes can see, down to the atomic level, where an entirely different kind of motion reveals itself. Every atom in your body is like a tiny galaxy, with electrons orbiting a nucleus like planets around a sun. But even this image, as helpful as it is, doesn't capture the full strangeness of atomic motion. Your atoms are vibrating. Right now, the atoms in your skin, in your bones, in every cell of your body are jiggling and dancing with thermal energy. This isn't a metaphor, it's the literal truth. Temperature itself is nothing more than the average speed of atomic motion. The warmth you feel from your blanket is actually the sensation of faster moving atoms in the blanket, transferring some of their energy to the slower moving atoms in your skin. When you touch something hot, you're feeling atoms that are dancing frantically. When you touch something cold, you're feeling atoms that are dancing more slowly. But here's the extraordinary thing. They're never not dancing. Even if we could cool something down to absolute zero, the coldest possible temperature where we might expect all motion to cease, quantum mechanics tells us that atoms would still vibrate with what's called zero-point energy. This is the universe's most fundamental rule. Nothing is ever truly still. Motion isn't something that happens to matter. Motion, is part of what matter is. To exist is to move. To be is to vibrate. Even in the deepest cold of intergalactic space, even in conditions we can barely imagine, particles tremble with an energy that cannot be extracted or eliminated. It's as if the universe itself has an irreducible restlessness built into its very foundations. Imagine looking at your city from an airplane at night. From that height, the city looks still, peaceful, just a spread of lights against the darkness. But you know that down in those streets, there's constant movement, cars navigating intersections, people walking home, elevators rising and falling in buildings. The stillness is an illusion created by distance. The same is true for everything you see around you. That seemingly solid, motionless wall is actually trillions of atoms in constant motion, but you're too large, too far away in scale to see the dance. This dance of atoms becomes even more beautiful when we realize it's not random. The atoms in your body aren't just jiggling chaotically. They're vibrating in patterns, creating waves of motion that propagate through your being. When you speak, your vocal cords create pressure waves that travel through the air as sound. When your heart beats, it sends pressure waves through your blood that can be felt as your pulse. You are a symphony of vibrations, a composition of waves and rhythms operating at scales from the molecular to the mechanical. And this brings us to something profound about what you are. You're not a thing, you're a pattern. You're not static matter, you're a dynamic process. The atoms that make up your body are constantly being exchanged with your environment. With every breath, you expel atoms that were part of you and incorporate new ones. The food you eat becomes you. The you from a moment ago becomes air and heat and waste. Scientists estimate that roughly 98% of the atoms in your body are replaced every year. So what persists? What remains constant if the physical matter is always changing? What persists is the pattern, the dance, the arrangement of matter and energy that creates the experience of you. You're like a wave moving through water. The wave isn't the water itself. Water molecules don't travel with the wave. Instead, each molecule moves in a small circle, passing the wave pattern to the next molecule. The wave is pure pattern, pure motion, yet it has identity, continuity, even purpose. You are like that wave, a pattern of matter and energy maintaining its form while constantly exchanging its substance with the universe around it. This isn't just poetic language, it's a description of physical reality. At the quantum level, particles don't even have definite positions until they're measured. They exist in what physicists call superposition, a state of being potentially anywhere within a certain probability cloud. The electron in a hydrogen atom isn't orbiting the nucleus like a planet around a sun. It's everywhere and nowhere, a cloud of possibility that only becomes definite when forced to by interaction. Let me share something that still fills me with wonder every time I think about it. The warmth you feel from your blanket isn't just atoms bumping into each other like tiny billiard balls. At the quantum level, heat transfer involves photons, particles of light in the infrared spectrum invisible to your eyes. Your blanket is literally glowing with invisible light, and that light is being absorbed by your skin, warming you. You're not just covered by a blanket, you're bathed in its invisible radiance. This hidden light show isn't unique to warm objects. Everything above absolute zero emits photons. You yourself are glowing right now with infrared light. If someone could see in the infrared spectrum, you'd appear luminous, radiating your heat signature into the night. You're not just in motion, you're in constant communication with everything around you through this exchange of photons. You're connected to your environment in ways that go far beyond simple physical contact. Temperature reveals itself as cosmic choreography. The faster atoms dance, the more energetic the photons they emit. It's all connected: motion, temperature, light as energy, different faces of the same fundamental phenomenon. When you feel cold, your atoms are dancing too slowly. When you feel hot, they're dancing too fast. Comfort is finding that sweet spot where your atomic dance matches your body's preferred rhythm. Think about water for a moment. In ice, water molecules are dancing slowly, confined to vibrating around fixed positions in a crystal lattice. As temperature rises, they dance faster until they break free from their positions and flow as liquid. Heat them more, and they dance so frantically they fly apart as steam. The same H2O molecules, but their dance determines whether they're solid, liquid, or gas. State of matter is just a description of how enthusiastically atoms are moving. Your body maintains its temperature through an intricate balance of these atomic dances. When you're too cold, your muscles shiver, large-scale motion creating small-scale atomic vibration, generating heat. When you're too hot, you sweat, water molecules dancing so vigorously they leap from your skin, carrying excess thermal energy away. You're constantly adjusting the tempo of your atomic symphony to maintain that narrow range where the chemistry of life can proceed. But motion goes even deeper than atoms. The particles that make up atoms, protons, neutrons, electrons, they're not solid little spheres. They're excitations in quantum fields, ripples in the fundamental fabric of reality. A proton isn't a thing. It's a stable pattern of energy in the quantum field. An electron isn't a particle. It's a wave of probability that collapses into particle-like behavior when measured. This is where our journey starts to touch the truly strange. Because if fundamental particles are really waves, patterns, excitations rather than things, then what we call matter is really just energy organized in particular ways. E equals mc squared isn't just an equation. It's a recognition that matter and energy are two faces of the same coin. Matter is frozen energy, energy moving in loops so tight it appears solid. Your body, your bed, the air you breathe, it's all energy in different configurations, different dances. The screen you're watching right now provides a perfect example of this quantum strangeness. The light coming from your screen is made of photons, but these photons weren't sitting inside your screen waiting to be released. They're created at the moment of emission, born from the energy of electrons changing their quantum states, and once created, these photons don't have a definite path from screen to eye. Quantum mechanics tells us they take all possible paths simultaneously, interfering with themselves like waves, until the moment they're absorbed by the rhodopsin molecules in your retina. This means the light entering your eyes right now doesn't have a classical trajectory. It's not like a tiny ball thrown from the screen to your eye. Instead, each photon exists as a wave of probability, exploring every possible route through space. Only when it interacts with your retina does this wave of possibility collapse into the experience of seeing. The very act of vision is a quantum process, collapsing infinite potential paths into the single reality of perception. We can go even deeper. Those electrons in your screen that are emitting photons, they don't have definite positions either. In the language of quantum mechanics, each electron exists in a superposition of states until measured. It's not just that we don't know where the electron is, it's that the electron doesn't have a definite position to know. It exists as a cloud of probability, potentially here and there and everywhere within its allowed region. This electron probability cloud isn't a limitation of our measurement tools or our understanding. It's a fundamental feature of reality. The electron really is in multiple places at once, or more accurately, it exists in a state where location itself isn't well defined. Only when we force it to reveal itself through measurement does it choose a specific position. And even then, that position is only momentary. The instant after measurement, it spreads out again into probability. This brings us face to face with one of the deepest mysteries in physics. What exactly causes this collapse from probability to actuality? What's special about measurement that forces indefinite quantum states to become definite classical ones? This is called the measurement problem, and after nearly a century of quantum mechanics, physicists still debate its solution. Some say consciousness is involved, some propose parallel universes, some suggest objective collapse, but all agree on the experimental facts. Until measured, quantum objects exist in superposition. You might wonder how this connects to your daily experience. After all, you don't see objects flickering in and out of existence or spreading out into probability clouds. Your coffee cup seems to stay put on your nightstand. It doesn't quantum tunnel through the floor. The reason is decoherence, the process by which quantum systems become entangled with their environment, effectively measuring each other constantly and suppressing quantum behavior at large scales. Every atom in your coffee cup is constantly interacting with air molecules, photons, and other atoms. These interactions act like measurements, collapsing quantum possibilities into classical realities billions of times per second. It's not that quantum mechanics stops working at large scales. It's that quantum effects get averaged out by countless interactions. The cup appears solid and definite because it's being measured continuously by its environment. But this raises a fascinating point. If everything is constantly in motion at the quantum level, if particles are probability waves until measured, if matter itself is just energy dancing in particular patterns, then what does it mean to say you're located somewhere? Your body is made of atoms in thermal motion. Those atoms are made of particles existing in probability clouds. Those particles are excitations in quantum fields that extend throughout all of space. When we trace motion from the cosmic to the quantum scale, we find movement everywhere. You're orbiting the sun, while the sun orbits the galaxy, while the galaxy moves through the cosmic web. Zoom in, and your atoms are vibrating while their electrons exist in probability clouds, while the whole system exchanges photons with its environment. There is no level of reality where true stillness exists. This realization transforms our understanding of what it means to be somewhere. Classical physics imagined objects with definite positions moving through absolute space. But quantum mechanics reveals that position itself is fuzzy, probabilistic, dependent on measurement. Relativity shows that motion is relative, that there's no cosmic reference frame to define absolute position. Together, they suggest that location is not a fundamental property, but an emergent one, arising from interactions and observations. You are not simply in your bed. You are a process occurring in your bed, a pattern of energy temporarily organized in a particular configuration, exchanging matter and energy with your surroundings while maintaining your form. You're a verb pretending to be a noun, a dance pretending to be a dancer. And this isn't just true of you, it's true of everything. The universe isn't made of things in motion, it's made of motion presenting itself as things. As you lie there, feeling still, you now know the truth. Stillness is an illusion created by shared motion. Solidity is an illusion created by rapid vibration. Location is an illusion created by measurement. You're not still, you're moving at cosmic speeds. You're not solid, you're mostly empty space with particles dancing at frequencies too fast to perceive. You're not simply here, you're a quantum process extended through space and time. This memory of motion, this truth that everything moves, prepares us for an even stranger journey. Because if motion is fundamental, if particles exist in probability clouds, if observation creates reality, then perhaps the question isn't whether you can be in two places at once. Perhaps the question is whether you're ever in just one place at all. And that brings us to our next exploration, the perspective of light itself, the view from a photon's frame of reference, where space contracts to nothing and time stands still. What does the universe look like to something moving at the ultimate speed limit? What can the journey of light teach us about the nature of presence and location? The photons from your screen have been waiting to tell you their story. In their world, Distance doesn't exist the way you think it does. In their world, the journey from star to eye takes no time at all. In their world, being in two places at once isn't just possible, it's the only way to exist. Imagine for a moment that you're not you. You're not. Measurement doesn't choose a specific position. And even then, that position is only momentary. The instant after measurement, it spreads out again into probability. This brings us face to face with one of the deepest mysteries in physics. What exactly causes this collapse from probability to actuality? What's special about measurement that forces indefinite quantum states to become definite classical ones? This is called the measurement problem, and after nearly a century of quantum mechanics, physicists still debate its solution. Some say consciousness is involved, some propose parallel universes, some suggest objective collapse, but all agree on the experimental facts. Until measured, quantum objects exist in superposition. You might wonder how this connects to your daily experience. After all, you don't see objects flickering in and out of existence or spreading out into probability clouds. Your coffee cup seems to stay put on your nightstand. It doesn't quantum tunnel through the floor. The reason is decoherence, the process by which quantum systems become entangled with their environment, effectively measuring each other constantly and suppressing quantum behavior at large scales. Every atom in your coffee cup is constantly interacting with air molecules, photons, and other atoms. These interactions act like measurements, collapsing quantum possibilities into classical realities billions of times per second. It's not that quantum mechanics stops working at large scales. It's that quantum effects get averaged out by countless interactions. The cup appears solid and definite because it's being measured continuously by its environment. But this raises a fascinating point. If everything is constantly in motion at the quantum level, if particles are probability waves until measured, if matter itself is just energy dancing in particular patterns, then what does it mean to say you're located somewhere? Your body is made of atoms in thermal motion. Those atoms are made of particles existing in probability clouds. Those particles are excitations in quantum fields that extend throughout all of space. When we trace motion from the cosmic to the quantum scale, we find movement everywhere. You're orbiting the sun, while the sun orbits the galaxy, while the galaxy moves through the cosmic web. Zoom in, and your atoms are vibrating while their electrons exist in probability clouds, while the whole system exchanges photons with its environment. There is no level of reality where true stillness exists. This realization transforms our understanding of what it means to be somewhere. Classical physics imagined objects with definite positions moving through absolute space. But quantum mechanics reveals that position itself is fuzzy, probabilistic, dependent on measurement. Relativity shows that motion is relative, that there's no cosmic reference frame to define absolute position. Together, they suggest that location is not a fundamental property, but an emergent one, arising from interactions and observations. You are not simply in your bed. You are a process occurring in your bed, a pattern of energy temporarily organized in a particular configuration, exchanging matter and energy with your surroundings while maintaining your form. You're a verb pretending to be a noun, a dance pretending to be a dancer. And this isn't just true of you, it's true of everything. The universe isn't made of things in motion, it's made of motion presenting itself as things. As you lie there, feeling still, you now know the truth. Stillness is an illusion created by shared motion. Solidity is an illusion created by rapid vibration. Location is an illusion created by measurement. You're not still, you're moving at cosmic speeds. You're not solid, you're mostly empty space with particles dancing at frequencies too fast to perceive. You're not simply here, you're a quantum process extended through space and time. This memory of motion, this truth that everything moves, prepares us for an even stranger journey. Because if motion is fundamental, if particles exist in probability clouds, if observation creates reality, then perhaps the question isn't whether you can be in two places at once. Perhaps the question is whether you're ever in just one place at all. And that brings us to our next exploration, the perspective of light itself, the view from a photon's frame of reference, where space contracts to nothing and time stands still. What does the universe look like to something moving at the ultimate speed limit? What can the journey of light teach us about the nature of presence and location? The photons from your screen have been waiting to tell you their story. In their world, distance doesn't exist the way you think it does. In their world, the journey from star to eye takes no time at all. In their world, being in two places at once isn't just possible, it's the only way to exist. Imagine for a moment that you're not you. You're not human, not made of atoms, not bound by the familiar rules of existence. You're a photon, a particle of light, and you've just been born in the heart of a distant star. This is your story, and it's unlike any story you've ever heard, because in your world, beginnings and endings happen in the same instant. You emerge from the fusion of hydrogen atoms, born from the marriage of matter that releases the energy of creation itself. In the star's core, where pressures and temperatures exceed anything on Earth, hydrogen nuclei overcome their mutual repulsion and fuse, releasing energy that has been waiting since the Big Bang to be freed. You are that energy, taking the form of a gamma-ray photon, beginning a journey that from your perspective will take no time at all. This is the first strange truth about being light. You don't experience time, not slowly, not differently. You simply don't experience it at all. From the moment of your birth to the moment of your absorption, no time passes for you. Whether your journey takes seconds or billions of years from an outside perspective, for you, it's all one eternal now. You are born and you die in the same instant, experiencing your entire existence as a single, timeless moment. Let me tell you why this happens, though the explanation might sound like magic. As you move through space at the speed of light, space itself contracts in your direction of motion. What others see as vast distances shrink to nothing from your perspective. The journey from the star's core to its surface, which might take 1,000 years from an outside view as you bounce between atoms, happens instantaneously for you. The voyage across light years of empty space to reach Earth passes in the same non-time. Distance, for you, doesn't exist. You are a dreamer who experiences all dreams at once. You are a story where every page exists simultaneously. You are a song where every note plays in the same eternal moment. This isn't poetry. It's the literal truth of special relativity. At the speed of light, the universe compresses to a point, and the flow of time stops entirely. You exist in a state that humans can barely imagine, everywhere along your path at once, experiencing your entire journey as a single, unified existence. But here's where your story becomes even stranger. You're not just a particle, you're also a wave. You ripple through space like a wave on an ocean that exists in dimensions humans can't see. And like a wave, you don't follow just one path. You explore all possible paths simultaneously. You spread out through space, flowing around obstacles, interfering with yourself, creating patterns of light and shadow that reveal your wave nature. Think of yourself as a ripple on a cosmic pond, expanding outward in all directions. But unlike water waves that slow down and fade, you always move at exactly the speed of light, never faster, never slower. It's the only speed you know, the only speed you can know. To move at any other speed would mean you're not light anymore. Your very existence is defined by this constant, universal velocity. The universe has a speed limit, and you are that limit made manifest. Nothing with mass can ever reach your speed, and you can never slow down to theirs. You exist in a realm apart, a state of being that massive objects can approach but never attain. You are what Einstein saw in his equations, the cosmic constant that links space and time, energy and matter, the speed that defines the very structure of space-time itself. As you travel, you carry information about your origin. The exact frequency of your oscillation tells the story of the atom that birthed you. If you emerged from hydrogen fusion, you vibrate at one frequency. If you came from the decay of an exotic particle, you dance to a different rhythm. You are a messenger, carrying news about events and places impossibly far away, delivering that news at the maximum speed the universe allows. But you're not traveling through empty space. Space itself is alive with fields and forces, quantum fluctuations and virtual particles. You interact with these fields as you pass, sometimes scattering off electrons, sometimes being absorbed and re-emitted, sometimes passing through matter as if it weren't there at all. Each interaction changes you, redirects you, but never slows you down. You can change direction, change frequency, even split into multiple photons, but you can never ever stop moving at the speed of light. Now let me tell you the most beautiful part of your story. Remember the double-slit experiment, that famous demonstration that reveals the quantum nature of reality? When light passes through two slits, it creates an interference pattern, proof that each photon somehow goes through both slits at once. You don't choose one path or the other. You take all available paths, interfering with yourself, creating patterns that speak of your wave nature. This isn't a limitation or a quirk. It's your superpower. You exist in superposition in all possible states until the moment of measurement. When scientists try to watch which slit you go through, the interference pattern disappears. The act of observation forces you to choose, to collapse from all possibilities into one actuality. But until that moment, you are pure potential, exploring every option the universe offers. Let me tell you this story as the fairy tale it truly is. Once upon a time, there was a particle of light that knew all paths. When it came to a fork in the road, or in this case, two slits in a barrier, it didn't agonize over which way to go. It went both ways. It went all ways. It was the path and the pathfinder, the journey and the destination. But whenever someone tried to spy on its choice, tried to peek at which road it took, something magical happened. The very act of looking forced it to choose just one path, to become less than it was, to trade its infinite potential for a single reality. This is your nature as light. You are possibility itself until the moment of observation. You don't have a path through space. You have all paths. You don't have a single story. You have every story that could be told. Only when you interact with matter, when you're absorbed by an atom or detected by an instrument, do you collapse from everything you could be into the one thing you are observed to be. Scientists call this wave-particle duality, but that name doesn't capture the magic of it. You're not sometimes a wave and sometimes a particle. You're always both and neither. You're something more fundamental, something for which human language has no proper word. You're a quantum of the electromagnetic field, a ripple in the fabric of reality itself, a piece of the universe's underlying structure, temporarily made manifest. As you continue your journey from that distant star, you carry with you the memory of every atom you've encountered. When you scatter off an electron, you exchange energy and momentum, changing both yourself and the electron. You might shift to a lower frequency, giving some of your energy to the electron, or you might gain energy, shifting to a higher frequency. Each interaction is a dance, a negotiation, a transformation that changes both partners. And now, after traveling for perhaps millions of years from a human perspective, but no time at all from yours, you approach Earth. To you, the star you left and the planet you're approaching exist at the same point. The distance between them has contracted to nothing. You are still touching the star that birthed you even as you're about to touch the eye that will absorb you. You exist at both places simultaneously because, for you, they are the same place. This is perhaps the hardest thing for humans to understand about your existence. You don't travel from star to Earth. From your perspective, the star and Earth are touching. Space has no meaning for you. You are the universe's way of connecting distant points, of making far things near, of proving that separation itself is an illusion that only makes sense at speeds less than yours. As you enter Earth's atmosphere, you might interact with air molecules, but these interactions don't slow you down. Nothing can slow light in a vacuum. When light appears to slow in materials like water or glass, what's really happening is absorption and re-emission. The original photon is absorbed, and a new one is emitted, creating the illusion of slower travel. But each individual photon, including you, always moves at exactly the speed of light. Now you're in someone's bedroom, approaching their eye as they watch a screen in the darkness. From their perspective, you've traveled across the room in a few nanoseconds. From your perspective, you're still at the screen, still in their eye, still at the star where you were born. All these locations exist at the same point in your contracted universe. You are demonstrating with your very existence that space and time are not the fixed stage we imagine, but are fluid, relative, dependent on motion. And here's where your story connects to theirs, to the human lying in bed absorbing photons like you, because they are made of atoms that have their own incredible stories. The hydrogen in their body, in the water that makes up most of their cells, those hydrogen atoms were born in the first few minutes after the Big Bang. They are nearly 14 billion years old, among the oldest things in the universe. But the heavier elements, the carbon in their DNA, the iron in their blood, the calcium in their bones, these were forged in the hearts of stars, just like you were. Some distant sun burned through its nuclear fuel, fusing lighter elements into heavier ones, until it could burn no more and exploded in a supernova. That explosion scattered these newly made atoms across space, where they eventually became part of the cloud that formed our solar system. Think about what this means. The viewer watching these words is literally made of star stuff. Not metaphorically, not poetically, but literally. Every atom heavier than hydrogen in their body was created in a star's core or in the violent explosions that mark stellar death. They are a collection of cosmic history, assembled from atoms that have traveled across the galaxy, that have been part of other worlds, other beings, other stories. The carbon atom in their fingertip might have been part of a diamond on some long-vanished planet. The oxygen they're breathing might have been in the atmosphere of a world that died before Earth was born. The iron in their blood might have been forged in a star that exploded when the universe was half its current age. They are not just in one place. They are a walking archive of everywhere the universe has been. This cosmic history is written in the very structure of atoms. Each element has a specific number of protons that defines what it is. But the arrangement of electrons, the energy states they occupy, these can tell the story of where that atom has been. Atoms bear the scars and memories of their journey through time and space. And now these well-traveled atoms have assembled themselves into a pattern that can think, that can wonder about its own origin, that can contemplate being in two places at once. But we haven't finished with your story, little photon. As you approach the human eye, you're about to demonstrate one more aspect of quantum reality. Until the moment you strike a rhodopsin molecule in their retina, you exist in superposition. You could hit any one of millions of light-sensitive cells. You could be absorbed here or there, or anywhere within the beam of light from the screen. You are potentially in all these places, a wave of possibility about to collapse into a single point of actuality. And when that collapse happens, when you're absorbed by that specific molecule in that specific cell, you cease to exist as a photon. Your energy is transferred to the molecule, changing its shape, triggering a cascade of chemical reactions that eventually results in a neural signal. You transform from light into chemistry, into electricity, into thought. The person becomes aware of that tiny bit of the screen, and you have completed your journey by becoming part of their consciousness. But here's what's remarkable. Quantum mechanics suggests that until that moment of absorption, you existed in all possible states. You were potentially absorbed by every possible molecule, triggering every possible neural response. Only the act of absorption, a form of measurement, collapsed these possibilities into one reality. In a very real sense, the act of seeing creates the reality of what is seen. This brings us to everyday experiences that mirror this quantum strangeness. Have you ever been in that drowsy state between sleep and waking where you're not quite sure where you are? For a moment, you might be in your childhood bedroom and your current one simultaneously. Your mind holds both possibilities until full consciousness forces you to choose, to collapse into one reality. This is your brain experiencing something like quantum superposition, or consider those times when you're deeply engaged in a memory. For those moments, aren't you in two places at once? Your body remains in the present, while your consciousness dwells in the past. You smell your grandmother's kitchen while sitting in your own. You feel the sand of a beach from years ago while lying in your bed. These experiences hint at the quantum nature of consciousness itself, the ability to exist in multiple states until observation or attention collapses them into one. Think about when you're having a conversation while your mind is elsewhere. Part of you is present, responding appropriately, while another part is planning dinner or replaying an earlier encounter. You're literally in two mental places at once, maintaining parallel tracks of awareness. This isn't a flaw or a distraction. It's evidence of your quantum nature, your ability to exist in superposition until circumstances force you to choose one state or another. Dreams take this even further. In dreams, you can be multiple people simultaneously, exist in impossible geometries, experience contradictory truths as equally real. Your dreaming mind doesn't insist on classical logic or single states of being. It embraces superposition, allows paradox, experiences the kind of reality that quantum mechanics describes. Perhaps dreams are windows into the quantum nature of consciousness, moments when the classical constraints relax and you experience reality more as a photon would. Even in waking life, you experience quantum-like phenomena. Have you ever had a word on the tip of your tongue? In that moment, the word exists in a superposition of almost remembered states. You know it's there, you can feel its shape and meaning, but it hasn't collapsed into specific syllables. Then, suddenly, often when you stop trying, it crystallizes into consciousness. The word was always there, in potential, waiting for the right conditions to manifest. Or consider creativity itself. Before you have an idea, where is it? The idea doesn't exist, then suddenly it does. But artists and inventors often describe feeling the idea approaching, sensing its presence before it fully forms. They speak of ideas as if they're already there, waiting to be discovered rather than created. This is the creative process as quantum collapse, infinite potential suddenly crystallizing into specific form. Your memories work this way too. They don't exist as fixed recordings, but as potential patterns that reconstruct themselves each time you remember. Each recollection is an act of quantum collapse, taking the superposition of possible memories and creating a specific experience. This is why memories can change, why 10 people can remember the same event differently. Each person is collapsing the quantum foam of possibility into their own unique reality. So as you lie there, made of ancient atoms that have traveled across the cosmos, experiencing consciousness that behaves like quantum systems, you are already demonstrating the answer to our question. You are in multiple places at once. You are in your bed and in the stars that made you. You are in the present and in every moment that led to now. You are a classical being experiencing yourself as solid and singular, and a quantum being existing in superposition and possibility. The photon's story is your story. Just as light exists as both wave and particle, you exist as both classical and quantum. Just as light takes all paths until measurement, you exist in all possibilities until choice or circumstance collapses them. Just as light connects distant points in space by experiencing no distance between them, you connect all the places you've been and will be through the quantum nature of consciousness and memory. You are not just made of star stuff. You are made of the same fundamental quantum fields as light itself. The only difference between you and a photon is the way energy moves through those fields. In light, it propagates freely at the cosmic speed limit. In you, it circles back on itself, creating the stable patterns we call matter. But at the deepest level, you and light are variations on the same theme, different songs sung by the same cosmic voice. And this prepares us for an even deeper mystery. If you are quantum at your core, if consciousness itself might operate by quantum principles, then what exactly collapses your superposition? What force chooses which of your many possible states becomes real? The answer might lie in the nature of observation itself, in the mysterious process by which possibility becomes actuality, potential becomes real, and the quantum wave of maybe crashes onto the shore of definitely. Picture consciousness not as a thing, but as a wave. Not contained in any single neuron, not located in any particular part of your brain, but emerging from the pattern of all your neural activity together. Like an ocean wave that isn't in any single water molecule, but arises from the coordinated motion of countless drops, your awareness isn't anywhere specific. It's everywhere in your brain at once, a distributed phenomenon that somehow maintains coherence and identity. This isn't just a metaphor. Neuroscientists have discovered that consciousness correlates with synchronized waves of electrical activity across different brain regions. Your thoughts, feelings, and sense of self emerge from these patterns of neural oscillation. You are, quite literally, a wave phenomenon, not solid, not located, but patterned and persistent. And like all waves, you exhibit behaviors that seem impossible from a particle perspective, but perfectly natural from a wave perspective. When you think a thought, it doesn't happen in one place. Networks of neurons across your brain fire in coordinated patterns, creating waves of electrochemical activity. These waves can interfere with each other, amplifying some thoughts while canceling others. They can resonate, creating moments of clarity and insight. They can fragment, leading to confusion or distraction. Your entire mental life is a symphony of interfering wave patterns, each thought a ripple in the electromagnetic field generated by your brain. But consciousness as a wave phenomenon goes deeper than just neural activity. What you experience as your continuous stream of awareness might actually be more like frames of a movie, discrete moments of consciousness arising and passing away so quickly they seem continuous. Buddhist meditators have reported this for millennia, describing consciousness as arising and passing away billions of times per second. Modern neuroscience is beginning to find evidence for this, suggesting consciousness might indeed be quantized, coming in discrete packets like photons of awareness. This wave nature of consciousness helps us understand one of quantum mechanics' most famous thought experiments in a new light. You've probably heard of Schrödinger's cat, the imaginary feline that is both alive and dead until someone opens the box to check. Usually, this is presented as a paradox, something disturbing about the nature of reality. But tonight, let me tell it as a lullaby, a gentle story about the universe's most fundamental truth. Once upon a time, There was a cat in a box. But this was no ordinary cat. This was a quantum cat, a cat that had learned the universe's deepest secret. While the box was closed, while no one was watching, the cat didn't have to choose between being alive or dead. It could be both. It could be neither. It could exist in that magical space between possibilities, experiencing all potential realities simultaneously. Think of this cat not as trapped between life and death, but as free from having to choose. In its superposition, it dreams all possible dreams at once. It purrs and doesn't purr. It sleeps and wakes. It exists in a state of pure potential, unforced into any single reality. The cat has achieved what mystics throughout history have sought, a state beyond duality, beyond the tyranny of either or. And here's the beautiful part. The cat isn't unusual. Everything in the universe exists in superposition until measured. Every particle, every atom, every molecule is like Schrödinger's cat, existing in multiple states simultaneously until interaction forces a choice. The universe is filled with invisible cats, all dreaming all possible dreams, all waiting for observation to crystallize one reality from infinite potential. This process, the collapse from superposition to definite state, happens through what physicists call decoherence. Let me paint you a picture of decoherence using something you've seen countless times: morning mist. In the pre-dawn hours, mist hangs over a lake like a veil between worlds. It's neither fully water nor fully air, but something in between, something ethereal and indefinite. You can see it but not grasp it. It's there but not there, real but intangible. As the sun rises and warms the air, something magical happens. The mist doesn't just disappear, it makes a choice. Each tiny droplet of water suspended in the air must decide, remain floating or fall back to the lake. As temperature and air currents change, as photons from the sun interact with the water molecules, the ethereal mist transforms into discrete droplets of dew. The indefinite becomes definite. The quantum-like becomes classical. This is exactly how quantum decoherence works. A quantum system, in superposition, is like that morning mist, indefinite, existing in multiple states at once. But when it interacts with its environment, when other particles bump into it, when photons scatter off it, when it becomes entangled with the larger world, it must choose a single state. The ethereal quantum mist condenses into the discrete droplets of classical reality. Your body is undergoing decoherence right now, billions of times per second. Every atom in your skin is constantly interacting with air molecules, with photons, with other atoms. These interactions act like measurements, forcing quantum indefiniteness to become classical definiteness. You appear solid and located not because you fundamentally are, but because you're being measured so frequently by your environment that your quantum nature never has time to fully express itself. But between these measurements, in those infinitesimal moments, between one interaction and the next, your atoms return to their natural state of superposition. You are constantly flickering between classical and quantum, definite and indefinite, located and distributed. It happens too fast to perceive, like frames of a movie creating the illusion of continuous motion. But the flickering is there, a fundamental feature of reality at the smallest scales. This brings us to something profound about measurement and observation. In quantum mechanics, measurement isn't passive, it's creative. The act of measurement doesn't discover a pre-existing reality. It creates reality from a spectrum of possibilities. This isn't mysticism or philosophy. It's what experiments consistently show. Until measured, particles don't have definite properties. The measurement itself forces the indefinite to become definite. Think about how this mirrors your own experience of making decisions. Before you decide, multiple options exist in your mind simultaneously. You can feel them all, weigh them all, imagine different futures spreading out from each choice. The decision doesn't exist yet. There's only potential. But the moment you choose, all those other possibilities collapse. One potential future becomes actual, while the others fade into might-have-beens. Your act of choosing creates reality from possibility. Or consider how memories work. A memory isn't sitting in your brain like a file in a computer, complete and unchanging. Instead, each time you remember something, you reconstruct it from distributed patterns of neural activity. The memory doesn't fully exist until you recall it. And each time you remember, you change the memory slightly, influenced by your current state, your recent experiences, your present emotions. The act of remembering creates the memory anew each time, collapsing potential patterns into actual experience. This creative aspect of observation extends to how you experience the present moment. Your brain doesn't passively receive sensory data. It actively constructs your experience from incomplete information. Your retina has a blind spot where the optic nerve connects, but you don't see a hole in your vision because your brain fills it in. You see color only in the center of your visual field, but your brain paints the periphery with remembered colors. Every moment, your consciousness is collapsing noisy, incomplete sensory data into the coherent experience you call reality. You are both the observer and the observed in this cosmic dance. When you look at your hand, you collapse its quantum possibilities into classical appearance. But simultaneously, your hand is observing you. The atoms in your hand are interacting with photons that have bounced off your face, collapsing your quantum possibilities too. You and your environment are engaged in mutual observation, mutually creating each other's reality through constant measurement. This mutual observation extends beyond the physical. When you interact with another person, you're both observing and being observed, both collapsing and being collapsed. Their observation of you influences who you become in that moment. We all know how differently we behave with different people. You literally become slightly different versions of yourself based on who's observing you, and you do the same to them. Relationships are mutual acts of reality creation, two quantum systems measuring each other into being. But where exactly are the boundaries in all this mutual observation? Where do you end and the rest of the universe begin? This question becomes even more profound when we consider what modern physics tells us about the nature of reality. According to quantum field theory, what we call particles are really excitations in underlying quantum fields that fill all of space. An electron isn't a tiny ball of stuff. It's a ripple in the electron field. A photon is a wave in the electromagnetic field. And these fields extend everywhere throughout the entire universe. This means that what you think of as your body is really a collection of excitations in various quantum fields. The electron field ripples in particular patterns that we call the electrons in your atoms. The quark fields dance in ways we call the protons and neutrons in your nuclei. You are not separate from these fields. You are these fields, organized temporarily into patterns that persist long enough to have experiences and memories and dreams. Imagine the universe as an infinite ocean, perfectly still and uniform. Now imagine waves arising on this ocean, some big, some small, some traveling alone, some in groups. These waves interact, sometimes amplifying each other, sometimes canceling out, creating complex interference patterns. What we call particles, atoms, molecules, and eventually people are just different types of waves on this cosmic ocean. We are not separate from the ocean. We are the ocean waving. This ocean metaphor helps us understand why separation is ultimately an illusion. Waves on an ocean might appear distinct, but they're all made of the same water. They can merge and split, exchange energy, create new patterns. Where exactly does one wave end and another begin. The boundaries we draw are conveniences, useful for description, but not fundamental to reality. The same is true for the boundaries between you and not you. Consider your breath. The air in your lungs. Is it you or not you? The oxygen molecules crossing from your alveoli into your bloodstream. At what exact moment do they transition from environment to self? The carbon dioxide you exhale, when precisely does it stop being you? These boundaries are impossible to define precisely because they're not real boundaries. They're arbitrary lines we draw in a continuous process of exchange. Even the boundaries of your body are far less definite than they appear. Your skin seems like a clear border between inside and outside, but look closer. Your skin is covered with bacteria, fungi, and other microorganisms, your microbiome. These organisms outnumber your human cells 10 to 1. They digest your food, regulate your immune system, even influence your mood and behavior. Are they you or not you? They have different DNA, but you couldn't survive without them. The boundary between self and other dissolves into symbiosis. Go deeper still. The atoms at the surface of your skin are held in place by electromagnetic forces. But these forces extend beyond the atoms themselves, creating fields that interact with the fields of nearby atoms in the air. There's no sharp cutoff, no absolute boundary where your electromagnetic field ends and the air's begins. Instead, there's a gradual transition, a fuzzy border where you fade into your environment, like watercolor paint bleeding into wet paper. This fuzziness of boundaries becomes even more pronounced when we consider quantum entanglement. When particles interact, they can become entangled. Their quantum states become correlated in ways that persist even when they're separated. Every interaction creates entanglement, and you're interacting with your environment constantly. Photons bouncing off your skin become entangled with the electrons in your atoms. Air molecules colliding with your body carry away quantum information about you. Over your lifetime, you've become quantumly entangled with countless particles now scattered throughout the world. That sunlight that warmed your face last summer, those photons carried away quantum information about you. The air you breathed as a child, the water you've drunk, the food you've eaten, all have become entangled with you to some degree. In a very real sense, parts of you are distributed throughout the environment, quantum echoes of every interaction you've ever had. This distribution of self goes beyond just physical particles. Your thoughts and actions create ripples that spread outward through the world. A word you speak vibrates air molecules, which bump into other molecules, creating a cascade of interactions that theoretically continues forever, getting fainter but never truly disappearing. Every action you take rearranges the universe slightly, creating patterns that propagate outward like ripples on a pond. But unlike ripples on a pond that eventually fade to nothing, quantum information cannot be destroyed. This is one of the fundamental principles of quantum mechanics. Information is conserved. The patterns you create, the quantum correlations you establish, the entanglements you form, these persist in some form forever. You are constantly writing yourself into the quantum structure of the universe, becoming part of the eternal record of what has been. This brings us to a profound realization. If you are excitations in quantum fields that extend throughout the universe, if you're entangled with particles scattered across space and time, if your boundaries are fuzzy and indefinable, if you're constantly exchanging matter and energy with your environment, then in what sense are you localized to one place? You are not in the universe. You are a pattern the universe is making, a wave that has no shore because the ocean itself has no edge. Yet somehow, miraculously, this distributed pattern maintains coherence. Despite being spread out, entangled, and constantly changing, you experience yourself as a unified entity. This is perhaps the deepest mystery. How does the universe create the experience of being a separate self from patterns that are fundamentally inseparable from everything else? How does the wave know itself as a wave when it's made of the same motion as every other wave? The answer might lie in the nature of observation itself. You are a pattern that has developed the ability to observe itself and its surroundings. This self-observation creates a kind of recursive loop. You observe yourself observing yourself observing yourself. This self-referential observation might be what creates the persistent illusion of separation, the sense of being a distinct entity despite being fundamentally continuous with everything else. Think of it like a whirlpool in a stream. The whirlpool appears to be a separate thing, maintaining its shape and position. But it's not made of any fixed water molecules. Water constantly flows through it. It's purely a pattern, a self-sustaining organization of flow. And crucially, the whirlpool only exists because of its interaction with the surrounding stream. Without the stream, there could be no whirlpool. Yet the whirlpool influences the stream too, redirecting its flow, creating new patterns downstream. You are like that whirlpool, a self-sustaining pattern in the quantum fields of the universe, maintaining your form through constant interaction with your environment. You appear separate but are fundamentally inseparable. You seem to have boundaries, but are actually boundless. You experience yourself as local, but are actually distributed throughout space and time through quantum entanglement and field effects. This perspective transforms our understanding of death and continuity. If you are a pattern rather than a thing, if you're distributed rather than localized, if you're entangled with the universe rather than separate from it, then what exactly dies when your body stops functioning? The pattern dissipates, certainly, like a whirlpool losing its coherence when the stream changes course. But the water that made the whirlpool doesn't disappear. It continues flowing, perhaps forming new whirlpools downstream. Similarly, the quantum fields that express themselves as you don't vanish when your pattern dissolves. The information you've written into the universe through your interactions, the quantum entanglements you've formed, the ripples you've created, these continue. You don't disappear so much as you stop being localized, returning to the distributed state that is actually more fundamental than the temporary localization you experience as life. You go from being a wave to being the ocean, from being a pattern to being the potential for patterns. This isn't meant as consolation or spiritual comfort. It's a description of what physics tells us about the nature of reality. Information is conserved. Quantum entanglements persist. The fields that manifest as particles are eternal and omnipresent. What we call death is a reorganization, not an annihilation. The universe doesn't lose anything when a pattern dissolves. It simply rearranges itself into new configurations, new possibilities, new expressions of the same underlying reality. But let's return to the living moment, to this experience of being a coherent pattern aware of itself. Right now, as you lie there listening, you are performing the universe's most astonishing trick. You are a wave that knows it's a wave, an excitation in quantum fields that can contemplate quantum fields, a temporary arrangement of matter that can think about matter. You are the universe observing itself, creating itself through observation, collapsing its own possibilities into experiences. Every thought you think is the universe thinking about itself. Every feeling you feel is the universe experiencing itself subjectively. Every observation you make is the universe measuring itself, creating definite reality from indefinite potential. You are not a separate observer looking at the universe from outside. You are the universe's way of looking at itself from inside. You are an aperture through which the cosmos perceives itself, a mirror in which existence sees its own face. This self-observation creates strange loops and paradoxes. When you try to observe your own consciousness, who is doing the observing? When you attempt to find the boundary between observer and observed within yourself, Where is it? You can observe your thoughts, but who observes the one observing the thoughts? This infinite regress, this impossibility of fully capturing yourself as object because you're always also the subject, hints at consciousness being more fundamental than we usually imagine. Perhaps consciousness isn't something that emerges from complex arrangements of matter. Perhaps it's more like mass or charge, a fundamental property of the universe that becomes concentrated and organized in certain patterns. Just as mass warps space-time and charge creates electromagnetic fields, perhaps consciousness creates the subjective experience fields that we call awareness. You are a place where this universal consciousness has organized itself into self-reflection. As you contemplate these ideas, notice how your mind moves between different states. Sometimes you're focused, your thoughts coherent and directed like a laser beam. Other times you're diffuse, your awareness spread out like morning mist. Sometimes you're sharply located in the present moment. Other times you're distributed across memories and imaginings. You naturally move between particle-like and wave-like states of consciousness, demonstrating the same duality that physics finds at reality's foundation. This duality, this ability to be both focused and distributed, both separate and connected, both particle and wave, is not a problem to be solved, but a gift to be experienced. You don't have to choose between being an individual and being one with everything. You can be both, just as light is both particle and wave. You can experience yourself as a distinct pattern while knowing you're made of the same field stuff as everything else. You can be here and everywhere, now and everywhen, self and cosmos. The wave that knows no shore, that's what you are. A pattern in the infinite ocean of quantum fields, temporary but timeless, localized but universal, separate but inseparable. You rise from the ocean like a wave, distinct and beautiful, creating your unique interference patterns with all the other waves around you. And like all waves, you will eventually return to the ocean. But the ocean itself is eternal, and you are never separate from it, even at your peak of apparent individuality. So when we ask whether you can be in two places at once, we're asking the wrong question. The question assumes you're fundamentally localized, that being somewhere is your natural state, and being in multiple places would be the exception. But physics suggests the opposite. Your natural state and being in multiple places would be the exception. But physics suggests the opposite. Your natural state is to be distributed throughout the quantum fields that fill all of space. Being localized to one place is the exception, a temporary condition maintained by constant interaction with your environment. You're already in multiple places. You're where your body is, but you're also distributed through every particle you've ever interacted with. You're in the present, but through memory and anticipation, you're also in the past and future. You're in your physical location, but through quantum entanglement, you're connected to distant parts of the universe. The question isn't whether you can be in two places at once. It's how you manage to create the illusion of being in only one place at all. And this prepares us for an even deeper exploration. If you're naturally distributed, if consciousness might be a fundamental feature of the universe rather than an emergent property, if observation creates reality, then what happens when we consider the possibility that every observation creates not just one reality, but all possible realities? What if the wave function never truly collapses, but simply branches, creating parallel versions of you observing all possible outcomes? Let's dive into the many worlds that might contain the many versions of you. In 1935, Albert Einstein wrote a paper that revealed his deepest discomfort with the quantum mechanics he had helped create. Along with colleagues Podolsky and Rosen, he described a thought experiment that seemed to show quantum mechanics predicting something impossible, that two particles, once connected, could maintain an instantaneous correlation no matter how far apart they traveled. Einstein called this spukhaft Fernwirkung, spooky action at a distance, and he meant it as an insult, a reductio ad absurdum that would force physicists to admit quantum mechanics must be incomplete. But Einstein's discomfort wasn't a failure of his genius. It was profoundly human, the same resistance you might feel when asked to believe that someone you love on the other side of the world could know your thoughts instantly without any signal passing between you. Einstein believed in locality, the principle that objects are only influenced by their immediate surroundings. To influence something far away, you must send something across the intervening space, and that something cannot travel faster than light. This seemed so fundamental, so necessary for a sensible universe, that Einstein couldn't let it go. Let me tell you what troubled Einstein so deeply, but I'll tell it as a love story, because that's what entanglement really is, the universe's way of maintaining connections that transcend space and time. Imagine two dancers who have practiced together so long they move as one. They know each other's rhythms so perfectly that even when separated, even when placed in different rooms where they cannot see or hear each other, they continue to dance in perfect synchronization. Not because they're following the same memorized routine, but because they're still connected in some way that defies explanation. Now imagine these dancers are particles, perhaps two photons born together in the same atomic event. Quantum mechanics says these photons can be entangled, their properties correlated in a way that persists no matter how far apart they travel. Measure one photon's polarization, and you instantly know the other's, even if it's on the other side of the galaxy. Not because they agreed ahead of time what their polarizations would be, but because the measurement of one genuinely, instantaneously affects the other. This isn't science fiction. This is science fact, verified by countless experiments over the past 50 years. Einstein was wrong about quantum mechanics being incomplete, but he was right that entanglement is spooky. It violates our deepest intuitions about how the world works. It suggests that the universe has what I call gentle loopholes, ways for connections to persist that bypass the normal rules of space and time. The key insight came from a physicist named John Bell in 1964. He proved mathematically that if Einstein was right, if particles had definite properties before measurement and couldn't influence each other faster than light, then their correlations would be limited in specific ways. But quantum mechanics predicted correlations stronger than Bell's limit. It was a testable prediction. Either quantum mechanics was wrong or locality was an illusion. The experiments, when they finally became possible, vindicated quantum mechanics completely. Entangled particles do correlate more strongly than any local theory allows. They do maintain instantaneous connections across arbitrary distances. The universe really does permit spooky action at a distance. Einstein's deepest intuition about reality was wrong, and in its place, we discovered something far more beautiful, a universe where separation is never absolute, where connections once made can never be completely severed. Think about what this means. Every interaction creates entanglement. When two particles interact and then fly apart, they remain connected. When a photon bounces off an electron in your body, those particles become entangled. The photon carries away quantum information about the electron, and the electron retains quantum information about the photon. They are no longer independent entities, but parts of a larger quantum system that spans whatever distance separates them. You are creating entanglements constantly. Every photon that bounces off your skin, every air molecule that collides with your body, every cosmic ray that passes through you, each interaction creates a quantum connection that persists as those particles disperse into the world. You are not an isolated system, but a node in a vast network of quantum correlations extending throughout space and time. This isn't metaphorical. When physicists talk about entanglement, they mean actual, measurable correlations between particles. If we could track all the particles that have ever interacted with you and measure their quantum states, we would find they're not independent, but connected, their properties correlated in ways that reveal their shared history. You've written yourself into the quantum structure of the universe through countless acts of entanglement. But entanglement isn't just about particles in physics labs. There's growing evidence that quantum effects, including entanglement, play crucial roles in biological systems. Photosynthesis, for example, appears to use quantum coherence to transfer energy with near-perfect efficiency. When a photon is absorbed by a chlorophyll molecule, it doesn't take a single path to the reaction center. Instead, it exists in quantum superposition, exploring all possible paths simultaneously, automatically finding the most efficient route. Think about what this means. Plants are quantum computers, using entanglement and superposition to harvest sunlight more efficiently than any human-designed solar panel. Every leaf is a testament to quantum mechanics operating at room temperature, in wet, noisy biological systems where physicists once thought quantum effects couldn't survive. If plants can maintain quantum coherence in these conditions, what else might be possible? Some researchers suggest that birds navigate using quantum entanglement. Certain molecules in birds' eyes may exist in entangled states that are sensitive to Earth's magnetic field. The bird literally sees magnetic fields through quantum correlations, with entangled electron pairs acting as a biological compass. Migration routes spanning thousands of miles might be guided by the universe's spooky connections. Even more controversially, some scientists propose that consciousness itself might involve quantum entanglement. The brain is warm and noisy, seemingly hostile to delicate quantum states. But recent experiments have shown that quantum effects can survive in biological systems much longer than previously thought. If neurons can maintain quantum coherence even briefly, then your thoughts themselves might be entangled quantum states, your consciousness a symphony of correlated quantum processes. Whether or not consciousness is fundamentally quantum, there's no denying that you experience something very much like entanglement in your daily life. Think about those moments when you knew someone you love was in trouble, even though they were far away, or when you and a close friend had the same thought at the same moment, or when you felt a connection to a place or person that defied rational explanation. These experiences hint at connections that transcend classical physics. Every relationship you form creates entanglements at multiple levels. At the most literal level, you exchange particles. When you touch someone, electrons in your skin interact with electrons in theirs, creating quantum correlations. When you breathe the same air, you're exchanging molecules that carry quantum information. When you share a meal, you're incorporating atoms that were recently part of the other person's environment. You become quantumly entangled through these physical exchanges. But the entanglement goes deeper than just particle exchange. When you have a conversation, you're creating correlated mental states. The words you speak create sound waves that physically alter the other person's brain, creating patterns of neural activity correlated with your own. Your thoughts become entangled through the medium of language, creating persistent connections that can last a lifetime. Memory itself is a form of entanglement. When you remember someone, you're not accessing a static recording, but recreating a pattern of neural activity that's correlated with your original experience of them. That pattern was shaped by their presence, by the photons that bounced from them to your eyes, by the sound waves their voice created, by all the quantum interactions that occurred between you. In a very real sense, part of them exists in your memory, quantumly correlated with the original. This extends to every interaction you've ever had. That stranger you smiled at on the street, photons bounced between you, creating entanglement. That tree you sat under as a child, molecules were exchanged, quantum states correlated. That book you read that changed your life, The photons carrying the words created cascades of neural activity that remain correlated with the author's original thoughts. You are a walking collection of quantum entanglements connected to everything and everyone you've ever encountered. Let me guide you through a visualization that might help you feel these connections. Close your eyes for a moment if you'd like. Imagine golden threads extending from your body in all directions. Each thread represents a quantum entanglement, a correlation with some particle or system you've interacted with. See these threads stretching out through your walls, across your city, around the planet, even into space. Some threads connect you to people you love, thick, bright cords of connection formed by countless interactions. Others are gossamer thin, representing brief encounters that nonetheless created lasting quantum correlations. See threads reaching into the past, connecting you to places you've been, people you've known, experiences that shaped you. These aren't just memories, but actual quantum connections, correlations written into the fabric of space-time. Now expand your awareness further. See how your threads intersect with others, creating a vast web of quantum connections spanning the globe. Everyone you've ever met is connected not just to you, but to everyone they've met, creating a network of entanglement that includes all of humanity. We are not separate individuals, but nodes in a quantum web, each of us connected to all others through chains of interaction and correlation. This web extends beyond humanity. Every breath connects you to the atmosphere, to plants and animals, to the ocean from which water evaporates and falls as rain. Every step you take creates vibrations that ripple through the earth, correlating your quantum state with the planet itself. You eat food that grew from soil, incorporating atoms that were recently part of other living things, creating entanglements with the entire ecosystem. And it goes even further. The sunlight warming your skin entangles you with the sun. Cosmic rays passing through your body connect you to distant galaxies. The gravitational waves from colliding black holes that constantly wash over Earth subtly affect every particle in your body, creating correlations with events billions of light years away. You are entangled with the universe itself, connected to everything through the web of quantum correlations. This isn't just poetic language. It's what physics tells us about the nature of reality. Non-locality, the principle that quantum systems can maintain instantaneous correlations regardless of distance, means that here and there are not as separate as they appear. When two systems are entangled, they form a single quantum system that spans whatever distance separates them. In a sense, they're not in two places. They're in one extended place that our classical minds perceive as separate locations. Think about what this means for your own existence. Parts of you, particles that were once in your body, photons that bounced off your skin, air molecules that carried your scent, are now scattered across the world. And through entanglement, they remain connected to you. You are not contained within your skin, but extended throughout space, a distributed quantum system masquerading as a localized classical object. This distribution isn't random or meaningless. The pattern of your quantum correlations encodes information about your history, your interactions, your relationships. In the language of quantum information theory, you've written yourself into the universe's quantum state through every interaction you've ever had. This information can't be destroyed. It's protected by the fundamental laws of quantum mechanics. In a very real sense, you are immortal at the quantum level, your information preserved in the correlations you've created. But entanglement reveals something even more profound about the nature of reality. When quantum systems are entangled, measuring one system instantly affects the other, regardless of distance. This doesn't violate relativity, because no information travels faster than light. You can't use entanglement to send messages. But it does mean that reality itself is non-local. The universe doesn't consist of separate objects interacting across space. Instead, it's a single, undivided whole that only appears to have separate parts when we make measurements. This wholeness isn't mystical speculation. It's what the mathematics of quantum mechanics demands. The wave function of the universe, if such a thing exists, cannot be separated into independent parts. Every particle is entangled with others, creating chains of correlation that link everything to everything else. We perceive separate objects not because separation is fundamental, but because our measurements create the appearance of separation. Consider your own body in this light. You think of yourself as separate from your environment, but where exactly is the boundary? Every atom in your body is entangled with atoms outside your body. The electromagnetic fields generated by your neurons extend beyond your skull, interacting with fields from other sources. Your quantum state cannot be defined without including parts of your environment. You are not separate from the world, but a particular pattern within the world's quantum state. This perspective transforms how we understand connection and separation. When you feel isolated or alone, remember that at the quantum level, isolation is impossible. You are fundamentally entangled with the world around you, connected through correlations that transcend space and time. The feeling of separation is a classical illusion created by decoherence, not a quantum reality. The same applies to your connections with other people. When you love someone, you're not just experiencing an emotion, you're recognizing a deep truth about reality. You and they are quantumly entangled through all your shared experiences. Every conversation, every touch, every moment of eye contact has created correlations between your quantum states. Love might be the conscious recognition of entanglement, the felt experience of non-locality. This isn't to diminish love to mere physics, but to elevate physics to the level of love. Entanglement shows us that the universe itself is built on connection, on correlations that bind apparently separate things into unified wholes. The same phenomenon that Einstein found spooky is what makes deep connection possible. The universe has this gentle loophole, this way for separated things to remain united, because connection is more fundamental than separation. Even experiences of seemingly psychic connection might have a quantum basis. When you think of someone and they call, when you dream of a friend and learn they were thinking of you, when you feel a loved one's distress from far away, these could be manifestations of quantum entanglement scaled up to the macroscopic level. We don't yet fully understand how quantum effects might influence large-scale systems like brains, but the possibility remains tantalizingly open. What we do know is that entanglement is real, verified by thousands of experiments. We know that biological systems can maintain quantum coherence. We know that the brain operates at energy scales where quantum effects could be significant. And we know from our own experience that connections between people can feel instantaneous, boundaryless, inexplicable by classical physics. Perhaps love, empathy, and intuition are evolution's way of harnessing quantum entanglement for survival and thriving. As you lie there in the darkness, you can feel these connections if you pay attention. The warmth of your blanket is mediated by photons, creating entanglement between the blanket's atoms and your skin. The air you breathe has been breathed by countless others, creating chains of correlation, linking you to every breathing thing. The thoughts you think create electromagnetic fields that subtly influence the quantum states of nearby objects, writing your mental patterns into the world. You are not alone, can never be alone, because aloneness requires separation. And separation is what quantum mechanics tells us doesn't ultimately exist. You are a node in an infinite network of quantum correlations, a focal point where the universe has concentrated itself into self-awareness, but never separate from the whole. Every particle that has ever interacted with you remains correlated with your quantum state, creating an extended you that reaches across space and time. This extended self isn't bound by the light speed limit that constrains classical communication. Entanglement correlations are instantaneous, creating what physicists call non-local connections. When a particle entangled with one of your atoms is measured on the other side of the universe, your atom responds instantly, not because a signal traveled between them, but because they were never really separate. They are parts of a single quantum system that spans the cosmos. Think about the implications for our original question. If you're quantum entangled with particles throughout the universe, if your quantum state cannot be defined without including systems arbitrarily far away, if measurement of distant particles instantly affects your local quantum state, then in what meaningful sense are you localized to one place? You appear to be here because decoherence creates the illusion of classical locality. But at the quantum level, you're already everywhere you've ever been, and everywhere the particles you've interacted with have traveled. This is the universe's gentle loophole, its way of ensuring that nothing is ever truly lost, nothing ever completely separated. Every goodbye carries within it the promise of continued connection at the quantum level. Every ending is also a transformation, a redistribution of entanglements rather than their destruction. The universe doesn't know how to truly separate things because separation isn't in its vocabulary, only different patterns of correlation. As we near the end of this exploration of entanglement, let's return to Einstein's discomfort. He couldn't accept non-locality because it seemed to threaten the very notion of independent reality. If measuring a particle here instantly affects a particle there, then what happens to our concept of here and there as distinct locations? Einstein wanted a universe of separate objects interacting through local forces. What he got was a universe of interconnected processes maintaining non-local correlations. But perhaps Einstein's discomfort points to a deeper truth. Our classical intuitions evolved for surviving in a world of medium-sized objects moving at moderate speeds, rebel against quantum reality. We want clear boundaries, definite locations, independent existence. Quantum mechanics offers us something else: fuzzy boundaries, superposed locations, fundamental interdependence. The universe isn't built the way our classical minds expect, yet when we let go of classical expectations, we find something more beautiful than what we lost. Instead of isolated objects bouncing around in empty space, we discover a universe that is fundamentally relational. Properties don't exist in isolation, but emerge from interactions. Location isn't absolute, but relative. Separation isn't fundamental, but apparent. We lose the cold comfort of isolation, but gain the warm reality of connection. You are living proof of this quantum truth. Your consciousness emerges from countless quantum processes, maintaining coherence despite thermal noise. Your memories persist through correlated patterns of neural activity. Your relationships exist as real correlations between quantum systems. You navigate the world using intuitions that may tap into quantum entanglement. You are not a classical being living in a quantum universe. You are a quantum being who has learned to masquerade as classical. As you drift towards sleep, you might feel these quantum connections more directly. In the drowsy state between waking and sleeping, the classical world softens its grip. The boundaries of self become permeable. You might feel yourself extended, distributed, connected to distant places and people. This isn't illusion or imagination. It might be a glimpse of your true quantum nature when the decoherence of waking consciousness relaxes. Every person you've loved leaves quantum traces in your being. Every place you've cherished maintains correlations with your quantum state. Every moment of deep connection creates entanglements that persist across space and time. You carry within you a quantum record of every meaningful interaction, every transformative experience, every touch that mattered. They are not just memories, but living correlations, active connections that continue to influence your quantum state. So when we ask whether you can be in two places at once, entanglement provides a profound answer. You're not just in two places. You're in every place you've ever been, connected to everyone you've ever known, correlated with every particle you've ever interacted with. The miracle isn't that you can be in multiple places, but that you ever appear to be in just one place. That appearance is the achievement of decoherence, the mask that quantum reality wears in the classical world. But the mask is wearing thin. As we probe deeper into quantum mechanics, as we discover quantum effects in warm biological systems, as we begin to understand consciousness itself as possibly quantum in nature, we're realizing that the classical world is the exception, not the rule. The universe is quantum all the way down and all the way up. We are quantum beings in a quantum cosmos, temporarily pretending to be classical for the sake of survival and sanity. And this realization prepares us for an even stranger possibility. If you're already distributed through space via entanglement, already existing in multiple states until measurement forces a choice, already connected non-locally to distant parts of the universe, then perhaps the next step isn't such a leap. Perhaps every measurement, every choice, every quantum event doesn't collapse possibilities into one reality, but branches them into many. Perhaps you don't just exist in multiple places, but in multiple worlds. Right now, as you lie there, you might be deciding which side to sleep on. Should you turn to your left or your right? It seems like such a simple choice, so inconsequential. But what if I told you that in making this decision, you might be creating entire universes? What if every choice, no matter how small, branches reality into multiple versions, each as real as the one you experience? This isn't a fantasy. It's one of the most mathematically elegant interpretations of quantum mechanics proposed by physicist Hugh Everett in 1957. He asked a simple question. What if the wave function never collapses? What if instead of possibilities becoming one reality, all possibilities become real in parallel branches of existence? Tonight, let's explore this idea not as abstract physics, but as a bedtime story about all the versions of you that might exist in the quantum multiverse. Imagine reality as a garden of forking paths, where every quantum event creates a new branch. In one branch, a radioactive atom decays. In another, it doesn't. In one branch, a photon goes through the left slit. In another, the right. But here's the beautiful twist. Both branches are equally real. The universe doesn't choose one outcome. It realizes all outcomes in parallel realities that never interact again. At first, this might seem to apply only to tiny quantum events. But you are made of quantum particles, and their branching creates branches for you too. When you decide which side to sleep on, quantum events in your brain's neurons influence that decision. In the many worlds view, you make all possible decisions. There's a branch where you turned left, another where you turned right, and even one where you're still deciding. All these versions of you are equally real, each experiencing their branch as the only reality. Let's make this personal. Think back to the biggest decisions of your life. That job you took or didn't take. That person you asked out or let slip away. That moment when you said yes or no to an opportunity that changed everything. In the many worlds interpretation, you made all possible choices. There are versions of you living every life you might have led, experiencing every path you wondered about. The you who took that other job is real, working in a different city, living a parallel life. The you who married your first love is real, perhaps putting children to bed in a house you've never seen. The you who moved abroad, who became an artist instead of an accountant, who said yes to that adventure. They're all real, all living their lives in parallel branches of the quantum multiverse. This might sound overwhelming, even frightening, but consider it from another angle. No choice you make is ever truly final because other versions of you are exploring the alternatives. You haven't missed out on anything because somewhere another you is living that experience. Every path not taken is a path taken by another version of you. The multiverse ensures that all possibilities are explored, all stories are told, all lives are lived. But how can all these realities exist without interfering with each other? This is where decoherence becomes crucial. Remember how quantum systems become entangled with their environment, appearing to collapse into classical states? In many worlds, decoherence doesn't collapse the wave function, it partitions it. Each possible outcome becomes entangled with a different version of the environment, creating separate branches that can no longer interfere with each other. Think of it like a vast cosmic tree. At the quantum level, the trunk constantly sprouts new branches as particles undergo quantum events. These branches split and split again, creating an exponentially growing structure. But here's the key. Once branches separate, they can't merge back together. Each branch evolves independently, creating its own version of reality. And crucially, observers on each branch see only their own branch. They can't perceive the larger tree structure they're part of. You are on one branch of this cosmic tree right now. To you, it feels like the only branch because decoherence has separated you from all the others. You can't see or interact with your other selves on different branches. But according to many worlds, they're just as real as you are, lying in their own beds, listening to their own version of these words, perhaps making slightly different choices about which side to sleep on. This perspective transforms how we think about possibilities and regrets. That moment you wish you could redo, another version of you is living the alternative right now. That opportunity you missed, another you seized it. That person you lost, in another branch, you're still together. The multiverse is generously inclusive, ensuring that every possible story unfolds somewhere. But this raises profound questions about identity and consciousness. If there are countless versions of you across the multiverse, which one is the real you? Many worlds
suggest they all are. You're not a single individual, but a vast collection of parallel selves, each equally valid, each living their own complete life. The you listening to these words is just one facet of a much larger existence spanning countless realities. Let me share a thought experiment that physicists have wrestled with, but I'll tell it gently as a meditation on consciousness and continuity. Imagine a quantum event that has two possible outcomes. In one branch, you continue experiencing, in another, you don't. According to many worlds, both branches occur, but your consciousness, your subjective experience, can only follow the branches where you continue to exist. You naturally find yourself in the realities where you persist. This isn't about literal immortality, but about something more subtle. The idea that consciousness might be more persistent across realities than we imagine. In branches where you cease to exist, there's no you to experience that cessation. Your stream of consciousness always finds itself in branches where it continues. It's like a river that always finds a path downhill, naturally flowing into realities where experience persists. This might explain those moments when you narrowly avoid an accident and think, I could have died. In many worlds, perhaps you did, in other branches. But your consciousness, by its very nature, finds itself in the branches where you survived. Every close call might be a branching point where your awareness parts ways with versions of itself, continuing only where continuation is possible. But the branching isn't just about dramatic moments. It happens constantly at the quantum level, creating new versions of you with every passing second. The air molecules bouncing off your skin undergo quantum events. The photons entering your eyes collapse, or rather branch, in particular ways. Each neural firing in your brain involves quantum processes that spawn new branches. You are constantly splitting into parallel versions, each slightly different, each going their own way. This might sound lonely, all these versions of you separated forever by the walls of decoherence. But consider the strange experiences that might represent glimpses across branches. Déjà vu, that eerie feeling that you've lived this moment before. Could it be a resonance between branches that haven't fully separated? A moment where similar versions of you in nearby branches are experiencing nearly identical events? Or think about dreams, where the normal rules of reality don't apply. In dreams, you might be multiple people at once, exist in impossible spaces, experience contradictory truths simultaneously. What if dreams are windows into the quantum nature of consciousness, moments when your awareness isn't firmly anchored to one branch and can sense the presence of nearby alternatives? Those moments of inexplicable certainty about paths not taken might be more than imagination. When you feel absolutely sure you would have been happy in that other career, when you know with bone-deep certainty that you made the right or wrong choice, perhaps you're sensing information from other branches. Not through any physical signal, branches can't communicate once separated, but through some deeper resonance in the quantum structure of consciousness itself. Let me guide you through a visualization. Close your eyes if you'd like, and imagine yourself as a vast tree. Your current awareness is one leaf on one branch, but feel yourself extending back through the twigs and branches to the trunk, to all the branching points of your life. At each fork, feel how you extend in multiple directions. You're not just this one leaf, but the entire tree, experiencing yourself from countless perspectives simultaneously. Now imagine you could send a message to your other selves. What would you tell the you who made different choices? What would you want to hear from them? Perhaps that they're okay, that their path has its own joys and sorrows, that the grass isn't necessarily greener, but simply different in each reality. Feel the comfort in knowing that all possibilities are being explored, that no potential is truly lost. Some decisions feel heavier than others, don't they? A casual choice about what to have for breakfast feels light, inconsequential, but deciding whether to take a new job, whether to end a relationship, whether to have children, these feel weighty, significant. In many worlds, perhaps this weight comes from sensing how much branching such decisions create. Big choices spawn vastly different futures, creating versions of you whose lives diverge dramatically. Yet even small choices compound over time. The you who had coffee instead of tea this morning might make slightly different decisions throughout the day, leading to different conversations, different thoughts, different dreams. Over weeks and years, these tiny divergences accumulate, creating versions of you whose lives differ in
Every opportunity you missed, you seized. Every life you've imagined living, you're living right now. The quantum multiverse ensures that no possibility goes unexplored, no potential remains unrealized. And if all possible versions of you exist across parallel realities, if you're already everywhere you could possibly be, if every quantum event branches you into multiple versions, then the answer to our original question becomes clear. You don't just exist in two places at once. You exist in countless places, living countless lives, in a multiverse vast beyond imagination, yet as intimate as your next heartbeat. The many worlds of you stretch out across the quantum cosmos, like stars in an infinite sky. Each one shines with its own light, lives its own story, dreams its own dreams. And the miraculous thing is that you are all of them, not divided or diminished, but multiplied beyond measure, a consciousness so vast it requires a multiverse to contain all its possibilities. You are already everywhere you could ever be. Here's a mystery that has puzzled scientists and philosophers for centuries. How does the unified experience of you emerge from billions of separate neurons? Right now, as you listen to these words, approximately 86 billion neurons in your brain are firing in intricate patterns. Each neuron is a separate cell, physically distinct from its neighbors, communicating through chemical signals across tiny gaps. Yet somehow, from this vast collection of separate elements, a single, unified consciousness emerges. You. This is called the binding problem, and it's one of the deepest mysteries in neuroscience. How do all these separate neural processes bind together into one seamless experience. When you look at a red rose, different parts of your brain process its color, shape, texture, and scent. Yet you don't experience these as separate phenomena. You experience one unified rose. How does your brain accomplish this binding? How do billions of discrete events become one continuous experience? Traditional neuroscience struggles with this question because it treats the brain as a classical system. Neurons fire or don't fire. Synapses release chemicals or don't. Signals propagate at definite speeds along definite paths. But what if consciousness requires quantum mechanics to fully understand? What if the binding that creates unified experience happens not through classical processes, but through quantum coherence across neural networks? This isn't wild speculation. Serious scientists have proposed that consciousness might be fundamentally quantum in nature. Roger Penrose, one of the world's leading mathematical physicists, and Stuart Hameroff, an anesthesiologist studying how consciousness can be turned on and off, developed a theory called orchestrated objective reduction. They suggest that consciousness emerges from quantum processes in tiny structures called microtubules within neurons. Think of these microtubules as the strings of a cosmic violin. In Penrose and Hameroff's view, quantum vibrations in these microscopic structures create a kind of symphony, millions of tiny quantum instruments playing together to produce the music of consciousness. Each thought, each feeling, each moment of awareness corresponds to a particular pattern in this quantum orchestra. Your experience of being you is the subjective feel of these quantum vibrations resolving into classical states. But let's step back from the technical details and focus on what this means for your lived experience. If consciousness involves quantum processes, then every thought you think, every emotion you feel, every decision you make might be a quantum event. When you wonder what to have for breakfast, quantum superpositions in your brain represent different options. When you make a choice, the superpositions collapse into a single decision. Your consciousness doesn't just observe quantum collapse, it is quantum collapse experienced from the inside. This transforms how we understand the measurement problem in quantum mechanics. Physics tells us that quantum systems exist in superposition until measured, but it's never been clear what constitutes a measurement. If consciousness is what collapses wave functions, then awareness itself becomes the bridge between the quantum and classical worlds. Every moment of conscious experience is a moment of creation, transforming quantum possibilities into classical realities. Consider what you're doing right now. You're conscious of these words, aware of their meaning, experiencing thoughts and perhaps emotions in response. If consciousness is quantum, then you're not passively receiving information. You're actively collapsing quantum possibilities into the specific experience you're having. The words could evoke many possible thoughts and feelings. Your consciousness selects which possibilities become actual. You are literally creating your reality through the act of observation. This explains why consciousness feels so different from everything else we know. The hard problem of consciousness, why there's something it's like to be you, why you have subjective experiences rather than just information processing, might require quantum mechanics to solve. Just as particles exhibit quantum properties that seem impossible from a classical perspective, consciousness exhibits properties that seem impossible from a purely neurological perspective. What are these properties? First, there's unity. Despite being generated by billions of separate neurons, consciousness feels singular. Then there's intentionality. Consciousness is always about something, always directed. There's qualia, the redness of red, the painfulness of pain, the subjective qualities that no amount of objective description can capture. And there's free will, the sense that you genuinely choose rather than merely executing predetermined neural programs. Classical neuroscience struggles to explain these features, but they emerge naturally if consciousness is quantum. Unity could arise from quantum coherence across neural networks. Intentionality could reflect consciousness as always being a measurement of something. Qualia could be what quantum state reduction feels like from the inside. Free will could be genuine if consciousness can influence which quantum possibilities become actual. Let me guide you through an exercise to explore your quantum consciousness. Focus on your awareness itself, not what you're aware of, but awareness as such. Notice how it's both everywhere and nowhere in your experience. You can't point to where consciousness is because it's what's doing the pointing. You can't observe it directly because it's what's doing the observing. This elusiveness isn't a bug, but a feature. Consciousness exhibits the same resistance to precise measurement that quantum systems do. Now shift your attention to the feeling of being both observer and observed. When you think about your own thoughts, who is doing the thinking about thinking? When you're aware of being aware, what's happening? This recursive self-reference creates strange loops that classical systems shouldn't be able to support, but which quantum systems naturally allow. You are simultaneously the quantum system being measured and the consciousness doing the measuring, both the collapsed wave function and the agent of collapse. This dual nature might explain why meditation and altered states of consciousness can feel so profound. In ordinary waking consciousness, you're firmly anchored to one branch of reality, one collapsed state. But in deep meditation, as the usual mental chatter quiets, you might begin to experience something closer to quantum superposition. The boundaries between self and other soften. Time becomes fluid. You feel distributed rather than localized, everywhere and nowhere simultaneously. Experienced meditators often report states where the observer-observed duality dissolves. They describe consciousness without an object, awareness without content, being without boundaries. These might be glimpses of consciousness in its quantum ground state, not focused on any particular possibility, but resting in the potential for all possibilities. The peace people find in such states might come from temporarily escaping the constant collapse of possibilities into actualities that characterizes normal waking consciousness. Even in ordinary life, you experience hints of your quantum nature. That moment when a solution to a problem suddenly appears fully formed in your mind. Where was it before? Not in your conscious awareness, yet somehow accessible. The creative process often feels like reaching into a space of pure potential and drawing forth something specific. Artists and scientists alike describe inspiration as discovering rather than creating, as if all possibilities exist in some quantum realm and consciousness simply selects which ones to manifest. Dreams offer another window into quantum consciousness. In dreams, you routinely violate the laws of classical physics. You're in multiple places at once. You transform from one identity to another. You experience impossible geometries and contradictory truths. Dream logic resembles quantum logic more than classical logic. Perhaps when the constraints of waking consciousness relax, you experience reality more as a quantum system would. All possibilities that simultaneously present until observation creates specific experience. But if consciousness is quantum, where exactly is it located? This question reveals a fundamental category error. Asking where consciousness is located is like asking where a wave is located. The question assumes consciousness is a thing in space rather than a process in space-time. You're not in your brain any more than a symphony is in the violin. The violin is necessary for the symphony, but the music exists in the patterns of vibration, not in the wood and strings.
Similarly, your brain is necessary for consciousness, but consciousness exists in the patterns of quantum coherence, not in the neurons themselves. These patterns extend beyond your skull through electromagnetic fields. They reach into the environment through quantum entanglement. They connect across time through memory and anticipation. Consciousness isn't localized because it's fundamentally a non-local phenomenon, a pattern in the quantum fields that happen to be concentrated in your brain but not confined to it. This view radically transforms our understanding of death and continuity. If consciousness is a pattern of quantum information, and if quantum information cannot be destroyed, then what happens when the brain stops functioning? The pattern dissipates, certainly, like a whirlpool dissolving when the river changes course. But the information that comprised the pattern doesn't vanish. It spreads out, decoherent, no longer organized into self-awareness, but not gone from the universe. This isn't mystical speculation, but a logical consequence of quantum mechanics. Information conservation is a fundamental principle. The quantum correlations you've created, the entanglements you've formed, the measurements you've made, these persist even when the measuring apparatus of your brain ceases to function. You don't disappear so much as you stop being localized, returning to the distributed state that quantum fields naturally prefer. As we conclude this exploration of consciousness and quantum mechanics, we're left with a profound shift in perspective. You're not a classical being mysteriously generating consciousness from neural activity. You're a quantum process that has achieved the remarkable feat of self-awareness. Every moment of experience is a quantum event. Every thought collapses possibilities into actualities. Every feeling is the universe experiencing itself subjectively through the aperture of your awareness. The question, where are you really, has an answer both simple and mind-bending. You are where consciousness is happening, not in any specific location, but in the process itself. You are a pattern of quantum events maintaining coherence against the tide of decoherence. You are the universe observing itself, measuring itself, creating itself through observation. You are fundamentally non-local, existing wherever the quantum fields that generate consciousness are active. And perhaps most remarkably, you are both unique and universal. Your particular pattern of consciousness, your specific way of collapsing possibilities into experience, is yours alone. Yet the consciousness itself, the capacity for awareness, might be a fundamental feature of the universe concentrated in certain patterns, but not created by them. You are a wave in an ocean of consciousness, temporarily risen to self-awareness but never separate from the source. Look up at your ceiling once more, but this time, imagine you can see through it to the stars beyond. Those points of light aren't really points at all. They're the endpoints of journeys that began years, centuries, millennia ago. The photons entering your eyes right now left their stellar homes when you were younger, when you were a child, perhaps before you were born. They've traveled across the vast emptiness of space, maintaining their quantum properties across impossible distances, to arrive at this exact moment in your retina. But here's what we've learned on our journey tonight. From the photon's perspective, no time has passed. The star that birthed it and your eye that receives it exist at the same point in its frame of reference. The photon doesn't experience the journey because, at light speed, the universe contracts to nothing. Past and present, here and there, collapse into an eternal now. The photon is simultaneously at its beginning and end, demonstrating with its very existence that our classical notions of space and time are convenient illusions. This starlight carries within it all the mysteries we've explored. It exhibits wave-particle duality, existing as both spread-out probability and point-like detection. It maintains quantum entanglement with the atom that emitted it, creating non-local connections across the cosmos. It takes all possible paths to reach you, interfering with itself in ways that reveal the quantum nature of reality. And when it finally strikes your retina, consciousness collapses its journey from possibility to experience. Through relativity and quantum mechanics, modern physics has completely dissolved our classical understanding of space and time. Einstein showed us that there's no universal now, no cosmic stage where events unfold in lockstep. What counts as simultaneous depends on your motion. Where you are depends on who's measuring. Time flows differently in different gravitational fields. Space itself expands and contracts based on relative velocity, the fixed grid of absolute space and time that Newton imagined.
Simply doesn't exist. Quantum mechanics goes even further, revealing that place itself is probabilistic until measured. Particles don't have definite positions, but exist in superpositions of all possible locations. The act of measurement doesn't discover where something is. It creates where something is from a spectrum of possibilities. Location isn't a property objects possess, but a relationship that emerges through interaction. You're not in a place so much as you're creating place through your observations and being created by the observations of others. What emerges from this twin revolution in physics is a picture of reality as fundamentally relational. You're not an object moving through absolute space, but a node in a vast web of relationships. Your position only has meaning relative to other things. Your motion only exists in comparison to other motions. Your very existence is defined not by what you are in isolation, but by how you interact with everything else. You are your relationships, and those relationships extend across all of space-time. Let's trace through the scales we've explored to see how this relational nature manifests at every level. At the cosmic scale, you're moving at incredible speeds, but this motion only has meaning relative to other objects. You're still relative to Earth, while hurtling around the sun relative to the sun, while spiraling around the galaxy relative to the galactic center. There's no absolute motion, only relationships between moving things. At the human scale, you appear solid and localized, but we've seen this as an approximation created by countless quantum measurements happening too fast to perceive. You're constantly exchanging particles with your environment, your boundaries fuzzy and indefinite. You're more process than thing, more verb than noun, maintaining your pattern through constant interaction rather than existing as a fixed entity. At the quantum scale, the particles that make up your body don't even have definite positions until measured. They exist as probability clouds, potentially here and there and everywhere within their allowed regions. Your solidity emerges from the statistical behavior of countless quantum possibilities collapsing into actualities through measurement. You are, quite literally, being created and recreated moment by moment through quantum observations. Think of a musical note traveling through air. Where is the note? Is it in any particular air molecule? No. The molecules just move back and forth slightly, passing the wave pattern along. The note exists in the pattern of compression and rarefaction in the relationship between molecules, not in any specific location. It's everywhere along its path, and nowhere in particular. You are like that note, a pattern propagating through the quantum fields, maintaining your form while constantly changing your substance. This understanding has profound implications for how we live. If you truly grasp that you're already distributed through quantum entanglement, that separation is an illusion created by decoherence, then the pain of being apart from loved ones transforms. Yes, you can't touch them or see them when they're distant, but at the quantum level, you remain connected. Every interaction you've shared created entanglements that persist across any distance. You carry each other within your quantum structure. Chapter 7. The Answer Hidden in Starlight, Integration, Part 2 of 2. Understanding your quantum multiplicity can ease anxiety about choices. If many worlds is correct, you don't have to agonize over decisions because all possibilities are explored across parallel branches. This doesn't mean choices don't matter. They matter immensely because they create realities. But you can release the fear of choosing wrongly because other versions of you are exploring the alternatives. Every path is taken somewhere in the multiverse. Feeling your cosmic connection addresses the deepest existential loneliness. You're not a separate being accidentally thrown into an indifferent universe. You're the universe itself, organized temporarily into self-awareness. Every atom in your body was forged in stars. Every quantum field that manifests as your particles extends throughout all space. You are as vast as the cosmos because you are the cosmos, looking at itself through the aperture of human consciousness. This brings us to the most profound question. If you're patterns rather than permanent particles, information rather than solid matter, what persists when your pattern dissipates? Death looms as the ultimate challenge to any sense of continuity or meaning. But quantum mechanics offers a radically different perspective on what dies and what endures. Consider what you actually are in light of everything we've explored. You're not the atoms that make up your body. Those are constantly being replaced. You're not even the specific quantum particles. Those are continuously exchanged with your environment. You're the pattern, the information, the specific way matter and energy organize themselves to create your unique consciousness and form. You're like a song made of ever-changing air molecules, a story written in constantly shifting ink. Quantum information theory tells us something remarkable. Information cannot be destroyed. It can be scrambled, dispersed, transformed beyond recognition, but the information itself persists. This is a fundamental law, as basic as conservation of energy. The pattern that is you, the information that defines your unique organization, cannot simply vanish from the universe. It transforms, certainly, but it doesn't disappear. When your brain ceases to function, the pattern of consciousness dissipates, like a whirlpool dissolving when the river changes course. The coherent, self-aware organization breaks down, but the information doesn't vanish. It spreads out into the environment. The quantum entanglements you've formed throughout your life persist. The correlations you've created continue. Every interaction you've ever had has written you into the quantum structure of the universe, and that writing is indelible. This isn't mystical thinking, but the logical consequence of physical law. Just as energy changes form but is never lost, information transforms but is never destroyed. The universe remembers everything, encoded in quantum correlations that persist forever. You don't achieve immortality in any personal sense, but you do achieve a kind of quantum persistence that transcends classical notions of existence and non-existence. What's more, if consciousness is truly fundamental to the universe, rather than emergent from complexity, then perhaps what we call death is simply consciousness returning to a less localized state. The wave function that temporarily organized itself into your individual awareness doesn't cease to exist. It just stops being focused into self-reflection. You go from being a wave with a specific shape to being the ocean itself. As we near the end of our journey, let's finally answer the question we began with. Can you be in two places at the same time? The answer is a resounding yes, but not in the way classical physics imagines. You're not a solid object that might somehow duplicate itself. Instead, you're already in multiple places through multiple mechanisms. Through quantum superposition, the particles that make up your body exist in probability clouds, potentially in many locations until measurement. Through entanglement, you're connected non-locally to every particle you've ever interacted with, effectively distributed throughout space. Through the constant exchange of matter with your environment, parts of you are always elsewhere, while parts of elsewhere are always in you. Through consciousness, which may be fundamentally non-local, you transcend the boundaries of your apparent physical form. In the many worlds interpretation, you literally exist in countless parallel realities, living every possible version of your life simultaneously. And through the relativistic nature of space-time, where simultaneity depends on reference frame, at the same time becomes a flexible concept. You are already in multiple places at once. The miracle is that you ever appear to be in just one place. You are quantum beings masquerading as classical objects, waves pretending to be particles, everywhere pretending to be somewhere. The solid, localized experience of everyday life is a magnificent achievement of decoherence, a careful balance between quantum possibility and classical actuality. But underneath that classical mask, you remain what you've always been, patterns in the quantum fields, temporarily organized into self-awareness, but never truly separate from the whole. So yes, you can be in two places at once. In fact, you've never been in just one place to begin with. You're distributed through space via entanglement, extended through time via memory and anticipation, multiplied across realities if many worlds is true, and fundamentally non-local if consciousness transcends classical boundaries. The question isn't whether you can be in multiple places, but how you manage to create such a convincing illusion of being in only one. The answer was hidden in starlight all along, in those photons that exist at both ends of their journey simultaneously, that take all paths to reach you, that collapse from everywhere to here only when consciousness observes them. You are like those photons, existing in the eternal now, where all places are one place, all times are one time, and the journey from everywhere to somewhere happens in the blink of an eye. You are here, in your room, in your bed. The familiar weight of the blanket rests gently across your body. The air carries a quiet stillness. Nothing moves, and yet everything does, even now. Let your body settle. Let your breath soften. Let your thoughts, like dandelion seeds in a summer wind, drift wherever they wish to go. Because tonight, the world you knew when your eyes first closed is not the world you're in now. Do you remember? The memory of motion hidden in stillness. The idea that nothing is ever truly still. That even your pillow is made of particles whispering between possibilities. The calmness you feel, yes, it's real. But underneath it, still a dance continues, not in defiance of peace, but as its partner. You are no longer a solid shape contained by walls and labels. You are the wave that knows no shore. You are spread wide now, like moonlight scattered across an ocean, present here and maybe there, maybe everywhere. As your awareness gently drifts through the softness of this moment, recall the photon, the one that dreams in silence, the one that moves without moving, that travels across light years in an instant, untouched by time. It doesn't decide where it is until someone looks. And you, quiet in your room, eyes closed, have become something like that. A presence suspended between what you feel and what you might feel, between where you are and where your memory wanders, between this moment and the next. This bed is not just a bed. It is a raft across probability. Each time you inhale, you rise on a wave of possibility. Each time you exhale, you let the world choose, softly, where you land. You are not just in this body. You are in the memory of a laugh, in the echo of a voice you love, in the faint reflection of yourself caught in a window once long ago. And even when morning comes, even when your feet touch the cold floor, you will carry this truth like a feather tucked in your pocket. You are more than one thing, more than one place, more than oneself. Let your mind wander again now to the gentle loophole, that cosmic trick of togetherness, entanglement, two particles once connected, no matter the distance between them, always know. A change here, a response there, not because they travel, because they are never truly apart. And if that's true of particles, then perhaps it's true of you. Think of someone you miss, not as far away, but as entangled. A thread between you glows faintly. No distance is too great for the whisper that travels along it. You are touching without touching. You are hearing without sound. In this room, in this breath, you are not alone, and you never were. That is not poetry. It is physics. It is the way reality folds around what we feel and names it truth. Take another breath. Feel how it arrives before you ask for it. Feel how the air was already waiting for you. Let your shoulders relax. Let gravity become something kind. The ceiling above you. Remember how you looked at it earlier? It looked like just a ceiling. But now you see it differently. You see that it's not a ceiling at all. It is a temporary agreement of atoms, nodding politely to one another. It is a surface painted in probability. A dance paused in mid-spin, held in place by your gaze, and when you close your eyes again, it returns to being uncertain, just like everything else. You are wrapped in a blanket of quantum truth now, not a mystery to be solved, but a lullaby to be hummed. You are here, and maybe also there. You are drifting, but not away. You're drifting inward, toward the center of a universe that has always been softly spinning inside you. Let your body rest. Feel the mattress beneath you as more than just fabric and foam. It's not holding you down, it's holding you here where the stardust remembers. Because you remember now, don't you, that everything you are was once a star, forged in the heart of ancient suns, elements born in violent brilliance, now resting as your skin, your bones, your breath. What a journey you've taken, from the collapse of galaxies to the rise and fall of your chest, to this very moment where you float in the quiet truth that you are eternal, not in body maybe, but in essence, in matter, in memory. You've looked up at the stars and wondered if they remember you, but the truth is, they never forgot. You are not a visitor in this universe. You are part of its unfolding. The quantum fabric that makes up everything, from the farthest nebula to the space behind your eyes, knows you intimately. And now, so do you. Breathe in again, slowly. Let the air be cool and silver as moonlight. Feel it ripple through you. Every molecule in your lungs once passed through mountains, oceans, forests. You've breathed the same air as tigers, as composers, as lovers who once whispered beneath the same moon that watches you now. Inhale and receive the memory of the world. Exhale and become part of it again. You are not separate. You were never separate. Do you remember the wave? That strange, soft thing that isn't quite particle, isn't quite place, until it's observed. That's what you are now. Unmeasured, uncollapsed, gentle. You exist in multiple possibilities. Your body lies still, but your mind is walking through forests of light, floating through dreams shaped like questions, falling upward into soft infinities. And all of this is real, because possibility is real, because your attention is enough to make the universe tilt toward presence. Tonight you are a photon, moving without moving, touching without touching, dreaming without sleeping, and all the metaphors, they were never just metaphors. The wave that knows no shore. That's your awareness. The particle's dream, that's your breath in the dark. The loophole of entanglement. That's your memory of someone who once held your hand. The many worlds. That's every choice you could have made, quietly holding space for the one you did. And now, as sleep approaches, like a shoreline bathed in fog, all those truths settle gently into the soil of your being, not to be held tightly, but to be known. There is no rush. There never was. There is only now, and now, and now again. Each moment, a new arrangement of the infinite. Each thought, a collapse of all that could be into all that is. You are the observer. You are the observed. You are the quiet decision the universe makes again and again. To be. So rest. Not because you are escaping the world, but because you are becoming it. Let your fingers grow heavy. Let your shoulders drop like stars falling toward a horizon of softness. Let your breath deepen until even the silence has rhythm. You have returned to the room, but not as the same person who left. And though it may all look the same, the blanket, the ceiling, the walls, You've changed, and because of that, everything has. Your breath is steady now, not because you tried, but because you remembered. Remembered that the breath is not something you control. It's something that carries you, like a tide, like the gentle pulse of space-time itself. Let your attention return, just for a moment, to the quiet weight of your body. How soft it feels against the fabric, how the mattress holds you like a question finally answered, how your ribs expand with trust and release with peace. You are not falling asleep. You are arriving, deeper, further inward, and maybe wider. Somewhere in another part of the world, someone else is lying down right now, listening, breathing, drifting between particles and thoughts just like you, and without ever touching, you are connected. That's not just comfort, it's science. It's the invisible quantum net we are all suspended in. So, if this journey made you feel less alone, more infinite, more curious than afraid, you're not the only one. Let this video become a shared ripple across distance, a wave you helped shape just by being part of it. Leave a gentle trace behind, leave a comment, and tell us where in the world you are drifting from. Maybe someone across the planet will whisper back. Maybe they already have. And if this quiet truth made something stir inside you, if it made you feel known, like maybe you've always suspected the universe was whispering to you, you were right. There are more questions waiting, more paradoxes to hold in your palm like a smooth, warm stone. Subscribe if you'd like to walk through them together. And when you do, whisper, "I'm listening," in the comments below. So we'll know the quantum thread reached you too. But for now, we come back to the body, not as a cage, but as a constellation. Scan it gently, from crown to toes. Let your forehead soften, unclench your jaw. Feel your spine sinking into the earth's patient arms. With each breath, you collapse another layer of the day's complexity into simplicity, into stillness. Your hands, feel them now, not just as flesh, but as fields, tiny galaxies, filled with spinning particles and quiet longing. And your chest, that soft temple of heartbeat and breath, each thump a ripple in space-time, each beat a signature that only you possess. This moment is yours, unrepeatable, infinite in its smallness. Do you feel it? That's not just the end of a video. It's a threshold, a curtain between the classical world you'll return to and the quantum wonder you now carry inside you. And it's okay that tomorrow things will seem ordinary again, that you'll drink coffee, check emails, forget. The illusion must return. Time must unfold. You must walk through it again. But this time, you'll know. Know that your presence changes the world just by observing it, that your attention has weight, that your very existence creates reality. This is the secret you keep, like a folded note under your pillow, like starlight held in a jar. You are not just dreaming. You are being dreamt by a universe that wanted to know itself, and it chose your shape. Now let go of the question, not to forget it, but to let it echo. Can you be in two places at the same time? Maybe. You already are.